Okay, so we are back. Thanks to those who are continuing to watch along and support me. Oh, I tell you what, this year is 10 times harder than it was last year. Last year, I was pretty chilled out. I had a few stressful questions in the middle of it all where I struggled. It was a simultaneous equation question. I just couldn't find the answer. A bit like the simultaneous equation question I had a minute ago, but I just couldn't seem to get it to work, even though it's a dead easy linear simultaneous equation question. This year, I just feel extremely tired. I am just really struggling. So let's carry on powering through. While my energy reserves are at a minimum, I'm gonna do a core 1 paper and a core 2 paper. So that's from the old A-level spec. Back in the day when I did my A-levels, it was what we call modular, which means, there's separate exams for separate units or separate modules. Whereas now, you get to the end of it, you just do 3 papers and that's it. And then each paper, it can ask you on the entire syllabus. It was a lot easier when I did it, admittedly. That's why I think if I do a couple of these papers now, I should be able to do them in about half an hour each. They're usually quite straightforward. So that just might make me feel a little bit more confident about my time. So let me edit my list here. So this is old spec A-level, core 1, and this is exam number 15. 15. So that is 10 to go over 8 hours. That's not too bad, not too bad. Considering that the only hard papers I've got left are the core 3 and the core 4. You can get some nasty calculus and stuff on there. And I have got a mechanics paper and a decision maths paper. And that's always neither here nor there as to how they're going to go, because they are not my strong suits by any means. I'm very much a pure mathematician, so give me a whole bunch of geometry, calculus, and that sort of thing any day. The mechanics, we'll see how that goes. So I'm just gonna go quiet for a while, put some music on, and see if I can power through these core 1 and core 2 papers. I really want to start making up some time. So bear with me on that. That was hard. That was a hard question. Just so much like wordy stuff. It's hard to even know what it was even asking. But actually, once you drew the picture and got everything down, it was reasonably clear. Oh, I thought that was the end of the paper, but it's not. Fine. And now it's over. hate the trapezium rule. I hate it. I hate it. I hate it. It's so boring. interesting. This came up actually. So when I was online with Creamer earlier on, I mentioned that I vaguely know the proof of this. So I should be able to do this. Put my money where my mouth is. So it's a good little proof actually. So you do. I think you do this. This isn't infinite, is it? So it goes up to. It's term 1. That's term 1. It's 2. Done. Done. Again, yeah, 2 in about an hour there. That's good time. That's good time. Stretch of the old legs. Okay, it's about 52.5 minutes per paper now. Seems more manageable. I've done some powering through. body is sore. Just gonna walk around for a minute. Come on. Come on. I think next I'm going to do this decision maths paper. Because it's a love-hate thing with decision. It's like a bit more, it's just a bit different from all the other stuff that we've been doing. So it's kind of a change of pace from all of the algebra and stuff like that. But there can be a lot of awkward questions on here. So I do need to concentrate. I'm just going to carry on listen to some music and try to push through. After this, I'm going to do the mechanics paper. These should take about 45 minutes each, I reckon. So if I can get these done by 6:30, yeah, that seems reasonable ish. I don't know anymore. I don't even know. Right. Did I remember to update that? Yes, I did. So this is now Decision Maths, paper 17. 8 papers to go. So not enjoying it at the moment. I'm feeling very tired. I feel very shivery. My back is absolutely killing me. My hand is absolutely killing me. The rest of my body is just in a lot of pain. So, come on. Right. Here we go. Bit of music. Oh, right. So, annoyingly, the answer paper to this I don't have. Why my Spotify decided to not work. Okay, yeah. So the answer book to this. Yeah. So I'll totally forget this. The decision, it usually comes with an answer book because there's some awkward like graph theory stuff in this, which is much easier to answer in the answer book, where a lot of it is like kind of set up for you. Oh, can't I be bothered? So the problem with not trying to look at the papers beforehand, like I did the same mistake with all of the A-level papers where there's just pages and pages of blank paper for the working out. I wish I'd just kind of looked ahead a little bit to decide which papers to print. Right, whatever. Anyway, let's just try and persevere. So that adds up to 219. So he definitely needs 5 rolls. Use the first fit bin packing algorithm to determine how these lengths can be cut. So bin 1, 20. Bin 2, 33, 19. Bin 3, 24. Bin 5, 31. 22 can go in that bin. 27. Let's go in a new bin. 18 can go in that bin. And 25 in a new bin. Carry out a bubble sort. So 20, 33, 19, 24, 31, 22, 27, 18, 25. So our computers sort numbers. So it compares. So we compare 20 and 33, put the bigger one on the right. Okay, and then that will bubble over to there, that will bubble over, that will bubble over. In fact, we are just peeling off that one. Okay, 19 will swap, 20 stays where it is, and then 24 stays where it is, 31, 27, 18, 25, 31, 33, 19, 20, 22, 24, 27, 18, 27, 25, 27, 31, 33, almost done. So annoying. Boy, that was very inefficient. Okay, and apply the first fit bin packing algorithm to show how these lengths may be cut from the rolls. So just doing it again. In bin 1, we've got 18. Then we've got 19. In bin 2, we'll take the 20, we'll take the 22. In bin 3, we'll take the 24 and the 25. It wanted them in descending order, so swap that order around. Yeah, because usually with the bin packing, you want to start with the biggest, don't you? So 33, 21, 31. Bin 3 will take 27. Bin 4 will take 25, and then it'll take 24, and then 22 can go in there, and then we need a new bin for 20, and then 19 can go in there, and then 18 can go in there. So we've done it in 5 bins, which is optimal because that's the lower bound. Okay, this is the matchings. So starting from this initial matching, right, so how do you do this again? So I think the algorithm goes, you start with G and put it somewhere where it'll go. So G connects to 5, and then scrub out 5 to E. And now E needs to go elsewhere, so we can take it to 4. Oh, and actually we're done. That was easy. Find another solution. Decision maths is a test of patience. So this time, I guess, if we take G to 3, so G connects to 3, scrub out 3 to C, and then C can connect to 2, which we delete to F, which we can connect to 1, which we can delete from D, and D send to 4. And then we've got E5, I guess. Yeah, that's fine. Right, so again, I don't have diagram 1 because that's in the blasted answer book, but fine, we'll just try and come on. Right, what a mess. So use Kruskal's algorithm. Okay, so we go with the smallest. Right, I'm getting another sheet of paper. What I'm going to do is I'm going to trace this. So BD goes in, ED for 10, CD for 12. What's the next highest? 13. We'll create a cycle, so ignore 14s. Do we have any 14s? No. So we go for a 15. Connect E to G. That's fine. And C to F is also 16, but would create a cycle, so ignore that. So with that. And actually, this is a spanning tree, so that's fine. State the weight of the minimum spanning tree. 76. Valency, I think that means the same as degree. So number of edges connected or incident to vertex. Okay, so the root inspection, so we have to find the vertices of odd degree. So that one, there's always an even number of them. So that's good, that's good, that's good, that's good, that's good. Maybe that's it then. No, that one, and that one. So we do ED. Oh my god, what on earth have we done there? That's 205 for that one. It's 206 for that one. So it's that we reject. So we do E to H and we do D to I. So this here is nonsense. So we add in that 64, we add in that 79, and we add in that 62. So if we no longer need that, then that is now even. That is now even. So we only need to worry about D to E. And the quickest way to do that is 131. So I'll also remove that. Given that the device may now start at any vertex and finish in any vertex, find the minimum inspection route. Well, if you can start at D, finish at E. This is semi-Eulerian, so it is just 1436 subtract 75 is 1361. Okay, Dijkstra's algorithm from S to T. Let's go. explain how you determine your shortest route. Subtraction. Due to flooding, the roads in and out of D are closed. That was wrong before. It's B-E-T at the end. So it's as above, because this avoids D anyway. Yeah, 45 plus 51, yeah, 68. Yeah, fine. Precedence table in the answer book. I don't have the answer book. Well, usually a precedence table is like, you've got the activities, and we've got the prerequisites. So A to K, I guess. Okay, so A is not dependent on anything, neither is B, neither is C. D and E are both dependent on A. F depends on B and E. G also depends on B and E. H depends on C. I depends on D and F. J depends on D, F, G, and C. And K depends on H. That's usually what a precedence table looks like. I don't know if that's exactly right because I can't see the answer book, but complete diagram 1 in the answer book to show clearly the early event times and the late event times. Okay, so on the early side of things, we've got 5, 9, and 14. So the earliest we can get to there is 9. The earliest we can get here is 14, because by the time that's done at 14, the earliest we can get there is 24. 9 plus 5. 28. As for the late times now, Wow, my pen is absolutely going crazy here. Yeah, that nib is like completely detached there. 24. That's all of them, isn't it? Yeah. So the float for activity E. So the float is like how long you can wait before you do it. So we could start it at 5. And then it takes 3. Which is 8. So, but we could delay it by 13 and we'd still be fine. So the float is 13. The lower bound for the number of workers needed to complete the minimum time. Okay, so the total time for all the activities is this. And the critical path is 28. It's going to turn out to be 3. So 2.2. So 3 workers minimum. And now schedule the activities using the minimum number of workers so the project is completed in the minimum time. So usually you get some like Gantt chart, we call it. So worker 1, worker 2, worker 3. Just do my best here. So worker 1 could do, well, one worker is always going to be on the critical path. Actually, that's the truth. So they do C, which is 14, and then they do H, which is 10, and then they do K, which is 4. Meanwhile, worker number 2 does A for 5. Yeah, I'm going to cluster these together. And then worker 3 does B for 9. Okay. Once A is done, you can do E. Once this guy is finished, B, then start G. Then do F, so D for 4. Then they do F for 2. you can do like F and like I and J there. Yeah, that's fine. 8, 9, 10, 11. Yeah, so something like that, you know. Easier if I actually had the Gantt chart. Oof, wow, hefty looking piece of graph paper there. It's going to be a linear programming question. I don't know why it's so cold. Please tell me this is the last question. Yes, it's the last question. Okay, a company is going to hire two types of cars, standard and luxury. Let X be the number of standard cars, let Y be the number of luxury cars. Okay, so X is bigger than 20. Y must be bigger than 8. And we've also got this line here, which is Y equals X. And Y must be less than or equal to X. The company decides at least 1/6 of the cars should be luxury cars. Okay, so Y plus X, that's the total number of cars. 1/6 of them, Y should be bigger than or equal to that. So Y plus X is less than or equal to 6Y, which means 5Y is greater than or equal to X. Okay, as required. Each time the cars are hired, they need to be prepared. It takes 5 hours to prepare a standard car. It takes 6 hours to prepare a luxury car. There are 300 hours available each week to prepare the cars. So okay, so we need Y equals 1/5 of X. Actually, it's usually easier. Yeah, I remember how to do it now. So 5x, so when x is 0, y equals 300 divided by 6, which is 50. And when y is 0, 300 divided by 5 is 60. So it's the easy way to draw that line. And that's 6 AM shading. Hence determine the feasible region and label it R. Done. The company expects to make £80 profit per week on each car. Therefore wishes to maximize 80x minus 80y. So we've essentially got y equals minus x. So 60, 60. We'll do it this way around actually. And we can see almost right away that this point here is going to be the good one. Yeah. I'll do. Okay, that was all right. That's a little bit longer than 45 minutes, I think, but whatever. So carrying on, let's do the mechanics paper next. Remember last year I was pleasantly surprised by how good I was at this, because I thought that this would be something that I'd struggle with, but it turned out to be okay. So let me update that list of papers. So we're still on mechanics. Come on, come on. So two particles A and B, mass of 5m and 2m respectively, are moving in opposite directions along the straight horizontal line. The particle collide directly immediately before the collisions. Right. So always draw a picture. We've got 5m moving with 3, and we've got 2m moving how do we know it's 4 actually, because it's only the speeds. No, I think this is right. Okay. So momentum before. That's the momentum before, and that has to be equal to the momentum after. So the momentum after they collide so it's gone bump, and it's gone to 5m times 0.8 plus 2m times the speed of b. That's what we're trying to work out. So 5 times 0.8 is 4. Why am I doing it on the calculator? 4m plus 2sb m. Cancel all the m's. So speed of b after is 1.5. In the collision, the magnitude of the impulse exerted on A by B is 3.3 newton seconds. Oh geez, what's impulse again? Impulse is change in momentum, I believe. So what is the change? That's m times delta v, since the masses are unchanged. And the speed has gone from 4 to 1.5. But actually it's gone from -4, and then it's changed to 1.5. So it's actually gone up by 5.5. So 3.3 over 5.5 is the mass of m. That looks like 3/5. That looks like m is 0.6. Yeah. Good. Okay, turning moments. Looks like a non-uniform rod AB. It's like 3 meters and a mass of 4.5 kilograms. The rod rests in equilibrium. Right, so we've got 4.5 G acting down there. And we've got the reaction at P is twice the reaction at Q. So if we call that R, then this is 2R. Find the magnitude of reaction of the support at Q. So moments about P then. We don't know what that distance is. can't be as simple as r equals 1.5, can it? Because 2r plus r, so total force down needs to be equal to total force of the direction up. So if (1.5g). So this is 0.7. So now we can do moments. Oh, I've done that mistake I was about to make last time. So call that x, and it's x. So x is equal to 1.6 times 1.5 g over 4.5. So this is going to be 1.6 on 3, 16 on 3. It's going to be 5 1/3. No, maybe not. Yeah. Alright, inclined plane. So a box of mass 5 kilograms lies on a rough plane, inclined at 30 degrees to the horizontal. The box is held in equilibrium by a horizontal force, magnitude 20N. Okay, so we've got 5G pulling down. We've got some reaction force R. And we've got some friction here, mu R. I think that's it. Now for the coefficient of friction. So we're going to resolve this way. So 5g sine 30 is equal to 20 sine 60 plus 32.44 mu. So 5 times 9.8 sine 30 subtract 20 sine 60 divided by 32.44. So mu is 0.22. Hey, you alright? How you doing?
How you doing?
Yeah, I'm alright. I'm not great, to be honest. I'm struggling. This was so much easier last year.
In what way?
I feel very, very tired. It's
Right.
almost
Yep.
like I've been doing this for 18 hours. And
Right. Yep.
I'm just being very slow, conscious of time. I've got a lot of easy papers left, which is good. Well, I've got the core 3 and the core 4, but they should be alright. And I've got my whole body is just really sore. I feel very tired. I just want to go to sleep. I just feel.
Understand that.
Yeah.
Yeah.
It's just yeah.
I can understand that, but you're doing well. You're keeping on time, which which is good.
This was so much easier last year.
Yeah. That's there's gonna be good years and bad years of these.
I don't know why.
Maybe next year it might be even harder.
I don't. Well, I'm getting older and older, aren't I? I don't know why this time it's just such. Yeah, I'm just really struggling with it. I knew as soon as I got up yesterday morning that it was a bad day for it, and unfortunately I couldn't change the day that I did it. I did not sleep very well. I just knew when I woke up, I'm like, oh, this is gonna be a struggle. I'm just so sore. I'm just, feels like I'm drunk without drinking any booze.
Right. Yep. No, I've been there.
Yeah, well.
Keep pushing through. Sometimes I get up a little stretch, or I make sure you're eating enough food and that you are warm enough as well.
Yeah, I feel
That's
my heating's on. I feel very shivery. Right, come on. Let's power through these. I don't want to sketch a speed time graph. Why did I think doing a mechanics paper and a decision paper was a good idea?
Doing a decision paper, I think, is a good idea.
I've just done the decision paper. I hated it.
D1 or D2?
It was D1.
I remember D2 being like super easy. No, D1 was the super easy one.
Yeah, it's easy. It's just like just awkward questions.
Yeah. All right, let's do this. Speed time graph.
Okay, so it's moving with 20. It starts at 20. It maintains a speed of 20 for 25 seconds. Then it goes with constant acceleration and deceleration down to 8. So that is at 25. That is 20. And then it goes down to 8. And it does that for 60 seconds. And then it moves with constant acceleration until it is again moving at 20. So something like that, I guess.
Yeah.
That distance there is 60. We don't know what that is yet. Because question B, find the time for which the car is decelerating. So it moves with deceleration 0.4. It starts at 20. So 20 minus 0.4 t is equal to 8. 0.4 t is equal to 12. 120 is equal to 40. T is equal to 30. So that's 55. And that's that must be 115. Okay. Given that the distance is that, find the time taken for the car to move from A to B. So I guess we don't know the acceleration, which means we don't know that. Let's call that x. But we know that the area of this entire thing will equal that, and then that will give us x. I think that's what it wants us to do. So this 1, 2, 3, 4. 1 is 25 by 20. 2 is it's a trapezium, so 30. 20 plus 8 over 2. High x 8 plus 20 over 2. Right. Okay, so 25 times 20 is 500. So 15 times 28 for this, or 20. 60 times 8, 480. Okay, so 1960. Take the 500, take the 480, take the 420, and this must equal 560. So 560 times 2 divided by 28, x is 40.
Nice.
Good little number there. So that means the total time taken is 115 plus 40, 155 seconds. Okay.
Wow, look at all the paper. It's like
so many words, so much paper, you know. A particle P is projected vertically upwards from a point A with, this is going to be a suvat question. I like these. With speed u. Okay, so the picture goes up. So its distance covered is 17.5. Its initial velocity is u. It moves freely under gravity until it reaches the ground with a speed of 28. Oh, hang on. So it starts here at 17.5 above the ground. So it goes up, it reaches some place, and then it goes back down. The particle, so A is minus 9.8 in our model. Final velocity, so I don't, how would I do this? So I think I'm going to do the final velocity is 0, because I'm going to find the exact moment it stops there. So I need to know the distance travelled. So v squared equals u squared plus 2as. So 0 is equal to u squared plus 2 times minus 9.8 times s. But we don't know what u is. So fine. Let's see how it goes. So u squared equals 19.6. And then the second scenario then, S, is we've got S, the total distance it's going to fall is now 17.5 plus u squared on 19.6. Starts with initial velocity 0, because it's right at that moment there. A, again, we'll model it going down, and then it reaches the ground with 28. So again, v squared equals u squared plus 2as. V squared is 28 squared plus equals 19.6s plus 2 9.8s. So 28 squared is that. So I'm going to divide by 19.6 plus 2 times 9.8. So S is 20. Now, what have I actually worked it out there? Oh, God.
Yeah, this one's a tricky one, actually.
196 times 20, and then square root it. Damn it. Yeah, I know I've made a mistake in the fact that I've defined S to be one thing, and then I've defined it to be another thing. So I've defined S to be that here, haven't I? That's what I did there. And then I defined the new S to be that. This just seems silly. Like, there's definitely an easier way to do this.
Yeah, no, but all the other suvats, have got time in it. You don't want that.
What about this then? What about the fact that if it goes up and it goes down, by the time it gets here again, it'll be moving with the same speed that it started at, because we're neglecting all the air resistances and stuff like that. So in fact, it goes up.
Squared equals u squared.
Yeah, so yeah.
And it's gone nowhere. And S is 0.
Yeah, exactly. So S is 0, U is U, V is U, A is still as minus 9.8. So v squared equals u squared plus 2a times 0. Oh, but what is that doing for us, you know? Ah, okay. But
Yeah,
it
because
is...
you've got everything there. Because v squared's u squared.
I know, but that's not gonna...
So you've got...
But what we can do...
Oh, yeah, shit, yeah, because that's just going to give everything 0.
So, but what we can do is starting with some initial velocity u, it's going to travel a distance down of 17.5. It's going to accelerate by 9.8. It starts with u and it finishes with 28 when it splats on the ground. Yes. So v squared equals u squared plus 2as. So 28 squared minus 2, 9.8, 17.5 is u squared. So root of 28 squared minus 2 lots of 9.8 lots of 17.5 equals 21. So u is 21. Okay, yeah, I think just didn't quite make the connection there. After t seconds after projection, p is 19 meters above a. Okay, so now we're starting from 21. We want t. We know that we're going 19 meters up. And what else do we know? We know that a is still minus 9.8 because we're going to go that way now. So it's going to be s equals ut plus half at squared. It is quadratic, which is good because it wants multiple values for t. So 21t minus 4.9 t squared. So 4.9 t squared minus 21t plus 19 is equal to 0. Let's just use the equation solver on here because it's the same as using the formula anyway. 4.9 minus 21, 19. So this gives me t is equal to basically 3 seconds and t is equal to 1.298 seconds. Why are the two different values of t? Well, I guess at that point it could be on its way up or it could be on its way down. The ground is soft, and after p reaches the ground, p sinks vertically downwards into the ground. Oh, come on, man. Before coming to rest.
It's quicksand.
Yeah. The mass of p is 4 kilograms, and the ground is assumed to exert a constant resistive force of magnitude 5,000. Find the vertical distance. Okay, what on earth? I've never seen a question like this before in my life. So it's going to go bang, and it's go whoop into there. So I suppose
You've got its acceleration. Is it? You got to turn that 5,000 newtons into. Yeah.
But we need to take into account the fact that it's smacking it at 28. Okay, so F equals ma.
Already got a force down.
So the force, the net force is 5,000 minus 4g. That's equal to 4 times a. So I think if we do 1 to 50 minus g, that is our acceleration upwards So it's starting with a velocity of 28, finishing with a velocity of 0 because we want the point it goes to null. So its acceleration. So its acceleration is going that way, which means its initial velocity that way. So I should do this the other way around. G minus 1/250. And what do we want? We want the distance it goes. So again, it's v squared equals u squared plus 2as. V squared is 0 plus 28 squared plus 2 times this g minus 1/250 times s. So 28 squared, and I'm expecting this to come out quite low. So it shouldn't go that far into the ground, should it? Really? And that's quite a big deceleration, so I'm expecting this to be very small actually. 0.3. So S is 0.316 meters. So it's going to go splat and it go down about 31 centimeters.
31 centimeters is quite far.
Yeah, it is. You know, it depends how soft the ground is. But it is.
Right, yeah, I mean, you wouldn't want it to be 0.3 centimeters.
No.
I guess, or 3 centimeters. Yeah.
And it's hitting with 28 meters per second, which is quite fast. Oh God!
Yeah.
You know, I went into that question quite optimistically because I usually like all that suvat stuff.
Yeah, but that I think that's a good question. It really tests if someone's paying attention there.
Yeah, it's true. It's true. So it's funny actually. I was talking to James about bearings and why on earth we still teach it at GCSE, and then his very good answer was the fact that it gets you used to defining a north and things, you know, in terms of your like canonical vectors. So, and here we are. So,
Never thought of it that way.
the ship has, I'm going to do it in column vectors because why not? Ship is moving with that velocity. Find the direction in which, as we're giving your answer as a bearing. So it goes minus 12 that way. It goes 7.5 up. So it's traveling along that vector. Let's call that theta. So tan theta is equal to 7.5 on 12. So arctan of 7.5 divided by 12. So that's 32. And then we need to add 270 to that because we always measure clockwise like that. So 302 degrees. Okay. At t hours afternoon, the position vector of S is vector S. When t is 0, S is that. Write down S in terms of t. Well, S is equal to 40 minus 6 plus minus 12, 7.5 times t, because that's per hour. If we like, we could write it like that. I can't be bothered with the I's and J's. So much cleaner just to write like that. A fixed beacon is at the point with position vector that. Find the distance of S from B when t equals 3. Okay, so the position vector of the boat at that point will be 4, 3, okay, calculate that, minus 6 plus 7.5 lots of 3 is 16.5. So we want the distance between that and 7, 12.5. So 4, 16.5, 7, 12.5. So it's going to be root of 3 squared plus 4 squared. Oh, there we go, 5. So it's a distance of 5 kilometers. Find the distance of S from B when S is due north of B. Right. So if it's due north, then they have the exact same I component. The beacon is at 7, so we want 40 minus 12t to be equal to 7. Ugh, that doesn't look good. T is 33 on 12. You don't like that. That doesn't seem right. I'm pretty sure I'm right about that. The I component has to be the same.
Yeah, no, you are. Yep.
If it's due north. So its position is that. I mean, there's nothing good is going to come from the fact that there's a 7 there. I don't know why I expected anything else really. Okay, so that's the time. So the distance. So what's its j component? Minus 6 plus 7.5 times 33 on 12. So we'll do 33 divided by 12 times 7.5. Subtract 6. Okay, so it's 117 on 8, or 14.65. And then we're comparing that with 12.5. Because if the I components are the same, then it is just a straight up j distance. So 14.65, subtract that, is 2.125 kilometers. That'll do. Okay.
Big stretch.
Yeah, I just feel awful. 2 particles, P and Q, have those kind of masses joined by a light horizontal rod. The system of the particles in the rod is at rest on a horizontal plane. Right, so it's 2 balls attached by a rod. That's a weird setup. At time t equals 0, a constant force F of magnitude 4 newtons is applied to F in the direction PQ as shown in the figure 3. The system moves under the action of this force until the time is 6 seconds, and during the motion, the resistance to the motion of P has constant magnitude 1 Newton, and the resistance to the motion of Q has constant magnitude 2 Newtons. What a meal that is. So this is 1 Newton that way, and that was 2 Newtons that way, right? The acceleration of the particles as the system moves under the action of F. So the resultant force is 1 Newton, and F equals ma, Newton's second law. So 1 is equal to the total mass of the system times A. So A is equal to 5 over 4, is it? Yeah, 5 over 4, or 1.25 meters per second squared. What is the speed of the particles at t equals s? Well, V equals U plus AT, right? So, and it starts from rest. So it is just 1.25 times 6. Seems very easy. 2 marks. Mildly suspicious about that.
No, I think that's right.
The tension in the rod. Oh god, how do you do this now? As the system moves under the action of F. So tension. So you have this kind of idea, don't you? So we've got the tension T. Oops, that's 1 Newton. 2 newtons. Okay.
Yep. Net force.
Yeah, so if we look at just this guy, as far as he's concerned, there is a net force of 1 Newton pulling it in that direction. So the tension has to be 2 newtons, does it? Is that how this works? Okay. Maybe this T minus 1. That's the net force on this guy, who has a mass of 0.3 kilos, and that is equal to 0.3 times its acceleration. I think this is it. So T is equal to 0.3, 1.25 plus 1. So 0.3 times 1.25 plus 1 equals 1.375. Now we should check that against our answer on this one. So as far as this guy is concerned, just to make sure I've not done something completely horrendous, we should be getting that 4 minus 2 minus t is equal to 0.5 times 1.25. So that's 4 subtracted is 2 minus 0.5 times 1.25 is equal to t. So 2 minus 0.5 times 1.25 equals 1.375. Okay, I'm fairly convinced, unless I've done it wrong on both counts. Fairly convinced.
You've got it good there.
Okay, so at t equals 6 seconds, the force is removed, and the system slides to rest. The resistances to motion are unchanged. Find the distance moved by F as the system decelerates. Okay. Well, what do we know? We know that it starts at a velocity of 7.5. I think we can work out A using F equals an A, because now we've got the body that's got a 3 Newton back force and a mass of 0.8 kilos. So 3 is equal to 0.8 A. So 3 divided by 0.8, but we should make it negative because it's going in that direction. So minus 3.75. We want to know the distance, and Yeesh. And it stops. So v squared equals 7.5 squared plus 2 minus 3.75 s, and that's 0, so it dies. So it's gonna be 7.5 squared divided by 2 times 3.75 equals 7.5.
5.
So 7.5 meters, and calculate the thrust in the rod as the system decelerates. I'm gonna treat myself to a whole new piece of paper to do this one.
Oh, very good. You.
Look at that. So we've got same kind of idea as before, except this time it's a thrust because it's kind of, pushing out against. So we've got the thrust T. We've still got the 1 Newton force here. And we've still got that. So now the total action on here is the fact that so F equals ma. We know it is decelerating with minus 3.75. We know it's got a mass of 0.3, and the resultant force is minus 1 subtract t, let's say. So t is equal to negative 1 plus 3.75 times 0.3, and that is equal to 3.75 times 0.3 times 0.3 subtract 1 equals an eighth. An answer so nice it can't be a coincidence. Yeah, quick double check on here then. So we've got that 2 Newton force. So F equals ma, which equals minus 3.75 times 0.5. And the resultant force here is actually going to be T, which is still pushing it forwards, minus 2. So it's going to be 2 minus 3.75 times 0.5, and it's an eighth. So fairly happy with that. And are we done? Yes, we're done. All right. Surprisingly,
Down. Yeah.
Surprisingly okay. That's the level of mechanics that I am happy with. Mechanics, Mechanics 2 was easy at college. Mechanics 3 I thought was very hard. And then any of the applied maths modules at university I found very challenging.
Yeah, they were always very fiddly, and I could never quite get it.
Yeah, remember the and here we have scalar r, vector r dot r hat.
R hat, yeah, over R hat dot.
Yeah, r double dot. So, just use a different letter. You know what I mean?
I
Right.
know, and then he'd throw a row in there, and you just go, oh, God.
Yeah, all bets are off. Right, I'll be back in just a moment.
Right, what we got next?
Oh, right, what have we got next? Well, I thought, yeah, just while I'm still half asleep, let's do these old GCSE papers, which should be a breeze because this is back when we did the GCSE and it was just like so easy. Um, so I'm hoping I can just speed through these. I reckon each one in less than half an hour. So I am just gonna really try and blitz through these. Maybe take us up to 8 o'clock. At which time I'll have 4 more papers left. So it's going to be a paper an hour. So I should comfortably be able to do this. So I've still got the core 3 and the core 4. And I've still got some GCSE papers. So these are like the easiest papers that I've got left. I just want to power through these and just give myself some time in the bank. God, I just feel so terrible. I can't even put it into words. I can't remember the last time I ever felt anything like this. It feels like I've,
Yeah.
you know,
How many coffees have you had?
none.
Good.
Although I give it a couple of hours, I might have a cup of tea just to perk me up a bit. So this is the old formula sheet. Probably recognise that. Kids get given a formula sheet this year to kind of mitigate the COVID absence of education. Yeah.
Well, I think that's kind of fine because in the real world, all you're doing is just Googling what the correct formula is anyway.
Yeah. I think it helps like to have some of these in your long term memory. But yeah. And I don't know. Memorizing the quadratic equation, it's a bit of a rite of passage, isn't it? You know. I am going to put more ink in my pen because for the third time it's run out, which is just insane. Like I said, I usually refill this about once a month, so I'll be back in 1 sec.
Thank you for your donation as well, Catherine. Oh, that's fantastic.
All right.
So I was just saying that we've just had a new donation come through.
Okay, that is Catherine, £49.36. I wonder what that could be about. Something.
Maybe some currency conversion in there.
I'm thinking something mathy. Or is it something to do with pi? Is it something to do with the fact that it takes it up to 769.36? I don't know. I reckon, knowing Catherine, there will be some relevance to that. I'm too tired to work it out. So, more ink in the old pen. I am not going to write with this hand for the rest of the Easter holidays once this is over. Okay. And it goes. And there we have it. So. Oh, it's yes, of course it is. It's in memory of that stressful logs question. So there's a lot. Were you awake for that? That logs question, I just could not seem to work it out. And then even after I got it right, I still convinced myself it was wrong, and it turned out to be log of 49 on 36. So that's what it was. Thank you for reminding me about that traumatic experience, Catherine. I really appreciate it. Okay, so the old school GCSE. Let's go. All right, let's do it. So, okay, let's go. Sam wants to find out the types of film people like best. He's going to. Oh God! Oh, already with the boring questions. So we were talking before about you know, how this just is not part of the GCSE anymore. You know, this kind of survey design. So a suitable. Okay, so comedy, action, sci-fi, tally, frequency. Is that what it wants? Sam.
Musicals.
Oh, you know, and the sorry chap who liked horror, I think just is not going to get a say. Sam collects his data by asking 10 students in his class at school. Give that might not be a good, may not generalize to whole population. Or what does James prefer the phrasing to be? May not be representative of the whole population, I think is what he likes. But James isn't here to argue with me, so we'll just have to leave it as that. Okay, the diagram shows the patio in the shape of a rectangle. Sure, Matthew is going to cover the patio with paving slabs. Each slab is a square of side 60. 32 of the paving slabs. Well, we are kind of restricted here, aren't we? So we have to go 6 across. So it's not a simple case of just finding the area. And we have to go 5 up. Because 5 times 60 is 3 meters. So it's a 6 by 5 array. So we need 30 slabs. So yes, he bought enough. Unless I've goofed. The paving slabs cost £8.63 each. Work out the total cost of the 32 paving slabs. Unbelievable. Unbelievable. So this is a non-calc paper. So 6, 12, 16, 9, 18, 20. Okay, so then it is going to be 6 plus 9 is 15, 11, 13, 4. So £43.15. Looks to be completely wrong, actually. I don't agree with that at all. Where have I gone wrong here? Oh, jeez, I've not put my magic 0 in. Can you believe it? 172609852. So 6, 11, 16, 7, 2. So 276.16. Now, how did I know that that was wrong? 32 times that, it's got to end in 6 because 2 times 3 is 6, and this didn't. So total rubbish there. And it should be approximately £9 by 30, so approximately £270. So I can definitely believe that is at least close enough to the answer that I'm not going to be bothered about going back to fix any of the little mistakes. Okay, Bill uses his van to deliver parcels. For each parcel Bill delivers, there is a fixed charge plus £1 for each mile. You can use the graph to find the total cost of having a parcel delivered by Bill. How much is the fixed charge? That is £10. Ed uses a van to deliver parcels. For each parcel, there is no fixed charge. Compare the cost. Okay, so Ed, no fixed charge. So we need a gradient here of 1.5, really, don't we? So for every 10 we go across, we're going to go 15. It's awkward. For every 20 we go across, we go 30 up. So it's gonna look something like that. So ed cheaper if d is less than 20. Otherwise, bill cheaper. I think that'll do, won't it?
That's right. Yeah.
Ordered stem and leaf diagram. Oh, come on. They took this off.
They're easy.
They took this off the GCSE for a reason, you know, because they didn't want students falling asleep during the exam. So one. Okay, any more 30s? We've got 3, 5, 6, 9. So let's do that. Okay, into the 40s. Oh, we've got a little 29 there as well. That's cheeky. So we've got 40. We've got 3, 3, 4, 9, 6, 2, 8. So in order, that is 2, 3, 3, 4, 6, 8, 9. That's all the 40s dealt with. And 2, 4, 5. Is that it? Okay. Oh, and actually, you usually have to put on a legend or a key to say 5, 2 means 52. Honestly, usually it's in the mark scheme. If you don't put the key or the legend, then
Really?
yeah,
Okay.
you don't get full marks. You can work out the amount of medicine to give a child by using that formula. So M is the age of the child. A is an adult dose. A child is 30 months old. An adult's dose is 40. Work out the amount of medicine you can give to the child. Okay, so the child's dose, is it just that?
I think so.
Right? Sure.
Yeah.
Right, whatever. So that's 30 times 5 times 8 over 150. Cancels. So 8 milliliters.
Yeah, for 2 marks, they're not asking you very much.
No, I guess not. It's boring. Okay, Liz makes some short cakes. She uses 25 ml of milk. So we're doing 2.5 of those. So that's 30. Robert has that much stuff. Work out the greatest number. So you can do 10 batches worth with the sugar. You can do 5 batches worth with the butter. You can do 5 batches worth with the flour. And you can do a ton of batches. So 5, so 60 shortcakes.
Yeah, see, I don't agree with this. I think that they should put some vanilla. I'd usually put some vanilla extract in there as well, just to make it a bit more tasty.
Yeah, well, you know, Liz and Robert have no interest in the vanilla flavoring.
No, they're boring.
So buses to Acton, leave the bus station every 24 minutes. Buses to Barton, leave the same bus station every 20 minutes. Both leave at 9. When will a next leave at the same time? So, okay, this is a lowest common multiple question, isn't it? So 120 is the lowest common multiple there. So at 11 a.m. I presume. Not done something stupid there, about. We've got to times that by 5. There's not going to be any more any closer than that. Okay, so expand 6y minus 15. Factorize completely for x plus y, 2x, and make h the subject of the formula. H is equal to 10t over g. You never get those basic algebra questions in the exam anymore.
I would love that to be, yeah, like I would just love I would love that question in a university exam.
Yeah, yeah, piece of cake. So it's
Hmm.
rotation of about 180 degrees. Doesn't matter about the direction because it's 180-degree rotation. It's a rotate around that. I wonder if there's any more answers to that. Don't think it's got a nice reflection about it. This could be an enlargement scale factor -1 about 3,3 actually. You could do it that way. I think that works. Yeah, but let's not. Let's not. Rail tickets and cheap trains. Oh, here you go, Dan. This is your question, isn't it? Are two websites selling train tickets. Each of the websites adds a credit card charge and a booking fee to the ticket price. Nadia wants to buy a
Better
train ticket.
websites, to be honest, but fine.
The ticket price is £60 on each website. Nadia will pay by credit card. Will it be cheaper? So it's 60 times 2.25 plus 0.8 with rail tickets, or it's 1.560 plus 1.9 with cheap trains. Let's see if cheap trains is worth its name. So this is 120 plus 15 plus 0.8. So that's 135.8. 1.5 times 60 is 90 plus 1.9. So 91.9. Wow, a lot cheaper there. That makes me think I've done something wrong.
Ooh.
Oh no. Oh god. Oh god. Yeah, this is just complete rubbish. So I need to find 2.25% of 60, don't I? So 1% is 0.6. So 2% is 1.2, and 0.25% is 0.15. So 1.35, that's the credit card charge. So it's 61.35 plus the 80 pence is 62.15. Here I need to find 1.5% of 60. So this is going to be 0.6 plus 0.3 is 0.9. So 60.9 plus 1.9 is going to be 62.8. So rail tickets is what we will go with. Okay, the diagram shows a parallelogram. Work out the value of x. Well, 2x plus 3x minus 15 must equal 180 because those angles are co-interior. So 5x is equal to 195. So x is equal to 39. Alright, that was easy enough. I suppose we could have done it by adding them all together and setting it equal to 360. Yeah, that's one way we could have done it.
Yep.
Fine. Jane has a carton of orange juice. The carton is a shape of a cuboid. The depth of the orange juice in the carton is 8 centimeters, right? So we've got that sort of deal. Jane closes the carton. Then she turns the carton over so it stands on the shaded face. Right. Work out the depth in centimeters of the orange juice. Now, okay, it's quite a nice little question, isn't it?
Hmm.
So that's the depth of 8. So the actual volume of liquid is going to be 6 times 8 times 10, which is 480. So if we do it this way, so this is 6 by 20 by some amount x that has to equal 480. So 120x is 4. So it's going to be 4 centimeters. That's fine. Oh, this is a classic. Absolute classic. It's so classic that it's actually become it's too easy now because we kind of drill the students on this. So 2 ways of doing it: interior or exterior. The exterior way is always easier. So that's 360 divided by 6. That's 360 divided by 8. We just need to add these now. So that's 60 plus 360 divided by 8. 360 divided by 8 is what is it? Well, it's the same as 180 on 4, which is the same as 90 on 2, which is the same as 45. So it's 105. Good. And more bearings. I can't bear the sight of them. Work out the real distance between... Okay, this is actually a scale drawing type thing. Luckily, I've got a ruler. So that's 7 centimeters. So it's 35 kilometers. Measure the bearing of H from L. Oh, and I still don't have a protractor or an angle measurer, as the Key Stage 2 paper called it. So I don't think I could do this.
Eyeball that one. Could you work it out? Could you work it out?
The bearing of H from L. So we're essentially finding this angle here, aren't we? Go on then, Dan. Just for you, I'll do some budge here, and I'll do some trigonometry. So this is 6.6. This we worked out to be 7. So let's call that phi. So we've got a right angle triangle. Obviously, it's not an exact measurement.
Still doesn't help.
I've had to.
Still doesn't help because this is a it's a calculator. It's a non-calculator paper, right?
Oh yeah, that's true. Yeah.
So you can put in a you can put in like a cosine of 6.6 over 7.
Yeah, so it's 90 plus inverse cos of 6.6 over 7, and that's my answer for that one. I really need a.
Can they take them? Can they take the marks away from you? I don't think they can.
No, because a bearing is a 3-digit number, so they're just not going to give you for that. Yes. Okay. A boat B is 20 kilometers away from H on a bearing of 40. Mark the position of boat B with a cross. Okay, so I would take my angle measurer and I would put it on 40 like that. Well, no, it would be more like that, wouldn't it? And then I would do that, and then I would go. I'd put a dot, and I'd take my ruler, and I would go measure it out by 4 centimeters, and that's how I would do that, and I would mark it with a cross. Unfortunately, I still do not have an angle measurer. I will absolutely have to get one should I ever do this again. Harry grows tomatoes. This year, he put his tomato plants into 2 groups, Group A and Group B. I gave fertilizer to tomato plants in Group B. Do not give fertilizer to the plants in Group B. He weighed 60 tomatoes from Group A. The cumulative frequency graph shows some information about these weights. Use the graph to find the median weight. So 30, 170. So the 60 tomatoes from Group A, alright, so this is a continuation, had a minimum of 153, a maximum of 186. The median we just found is 170. Now the lower quartile is at 50, which is at 165, and the upper quartile is at 45, which is at 175. So weirdly symmetrical box plot there. Okay, compare. So on average, Group A heavier, Now the interquartile range of this is 8. And the interquartile range of that is 5, 6, 7, 8, 9, 10. So group B, more consistent. That's always what you do. You compare the medians, you compare the interquartile ranges. Okay, simplify. So this is 1 over m to the power 10, or m to the minus 10 if you prefer. And factorize, we've got x, looks like a minus 2 plus 5 to me. Write down the value of 10 to the power 0, 1. Write that as an ordinary number. 6, 7, 0, 0, 0, 1, 2, 3, 4. Think that. 1, 2, 3, 4, 5. Okay, and that is 27 times 10 to the power of 13, which
wait. Sorry, no. B's minus 5.
Oh, yeah. Thanks. 1, 2, 3, 4, 5. Yeah. 1, 2, 3, 4, 5. Yeah. Good spot. So. Triangle PQR is an enlargement. Scale factor half. Center 0, 0. So it's gonna look like this. So it's gonna have 1.5. It's gonna like that, isn't it? Okay. Okay, so the area is half base times height, which is 1.5. Now, I think the better way to do that, actually, now that I've finished the question, is to just find the area of that one and then times it by a quarter, because that's a half squared. So the area of this one is 4 by 3 on 2. 4 times 3 is 12 on 2 is 6, divided by 4 is 1.5. Okay, so that seems to be consistent with that. Okay, so 0.6, 0.7, 0.3, 0.7. Work out the probability that Wendy wins at Hoopla and also wins on the Coconut Shy. 0.12, the product of the probabilities, assuming they're independent. Okay, solve the simultaneous equation. Oh god, I just had a nightmare of these on that GCSE paper. Okay, no clever trick to be done here, so we'll just do 15x plus 6y is equal to 33, and we'll do 8x minus 6y is equal to 36. So adding, we get 69 is equal to 23x, so x is equal to 3. So 15 plus 2y is equal to 11, so y is equal to minus 2. Okay, let's check our answer in there. We get 12, subtract 3 lots of minus 2, that's add 6 is 18, that's fine, so 3 minus 2. Okay, no nightmares on that one. Here we go. B, C, and D are points on the circumference of a circle, center O. A, B, okay, fine. Work out the size of angle B, C, D. So we want that. We know that that is 130, so we know that that is 65. Give a reason, because 90 plus 90 is 180, so 50 plus that has to equal 180, so that must equal 130, and then we half it because angles at the circumference are twice the angles at the, angles in the center are twice the angles at the circumference. They are my reasons.
Yep.
Oh, I've already drawn a histogram tonight. Come on. So the widths of all of these classes are like that. So the frequency densities will be 3, 5, 3.6, and 1.2. So 1, 2, 3, 4, 5. Yeah, let's do that. 2, 3, 4, frequency density. Okay, so between 60 and 65, we've got a frequency density of 3. Between, so going up to 7, we have 5. Going up to 80, we have 3.6. And going up to 100, we have 1.2. So, something that looks like this. Obviously, should be using a ruler, but work out an estimate for the number of cars with a speed of more than 85. So we just want the area of that. So it's 1.2, and that's 15. So 15 times 1.2, which is equal to 180. So 18. Well, it's 3/4 of whatever that is, isn't it? So
3/4.
Yeah, that's fine. Okay, simplify fully. Finally, some meaty algebra questions. So x is bound to factorize. So looks like +4 minus 1 over 2x. Now I'm gonna suspect we get that, which means I'm suspecting we get that. Let's just check to see if it works. So +3x. Oh, it does not work. Shouldn't have jumped the gun there.
-3.
Yes. Oh, hang on. So we need -3 and -1. Yeah, I suspected we get x is -1 because we have to cancel with the numerator there. So. -3, yeah, that's fine. Bang, bang. So x +4 over 2x -3. And now express as a fraction in its simplest form. So we get 4x subtract 8 plus 3x plus 6 over the product. Okay, so this is going to be 7x minus 2 over x squared minus 4. I don't think you can do anything else with that. That does not factorize, so let's leave it there. Express the recurring decimal. So we've got
X squared minus 4 factorizes.
It factorizes back out into that, isn't it? But you can't do anything with that.
Oh yeah, fair enough. Yeah.
So we got that. So we'll take let x equal that. So 100x is equal to 28.181. So now 99x is equal to 28. So that cancels with that. So it's equal to 28.1 subtract 0.2, which is equal to 27.9. So x is equal to 2790 over 990 over, sorry, 27.9 over 99. So it's that. Sorry. Now this does simplify a little bit. We can do 93 over 330. And I don't think we can simplify. Oh no, that simplifies 31.
3.
Yeah, there's another 3 in there. And that definitely will not simplify anymore. 31 is prime and 110 isn't a multiple of 31. A cylinder has base. Now, all through the night, it's been saying a circular cylinder, as if there is a different kind of cylinder, but here we are with just a straightforward cylinder this time.
It's solid.
Yeah, and it is. Boy, is it solid. Oh, this is a classic question as well. The old meltdown and reform. So we know the volume of the cylinder is 2x squared sorry, pi times 2x squared times 9x. And we know the volume of the sphere is 4/3 pi r cubed. So 4/3 pi r cubed is equal to this whole shebang. So 4x cubed pi times 9. I'm not losing any terms here, am I? Don't think so. So the 4 cancels with the 4, the pi cancels with the pi. So r cubed is equal to 27x cubed. So r is equal to 3x when we cube root it. That's nice. It turned out nicer than I thought it would be. Okay, y equals f of x. So f of x minus 3, we need to push it 3 over here. So it's going to look something like, we've got another key point there as well. 1, 2, 3, another point there as well. So it's going to look something like this. It's fine. And 2f of x. So we're going to stretch down to there. We're going to stretch up to there. We're going to still go through the axis at the same points, but it's going to look something like this. I'll do. And that's the paper. Okay, so fairly straightforward, really. All fine. All fine, as long as you read the question properly.
Through that one.
10 to the power of minus 5 and not 10 to the power of 5. Okay. Let's do another one. Let's do another. Alright, so yeah, just looking at some comments from James. Yes, you missed the GCSE. I did those 3 in the early hours of morning. And then I did the decision maths, and then I did the mechanics, and now I'm just busting out these old GCSEs. So we've got the higher paper 2 this time. The calculator paper, back in the day when there was only 2 papers on the GCSE, there's now 3. 1 non-calculator, 2 calculator. But they are slightly shorter as well, so these are an hour 45. So what's that? 5 to go, and we've got 4.5 hours. Should be all right. Should be all right. I just feel so cold. I just feel bad. I'm just gonna get my.
You get like another jumper. Yeah, get another jumper or get a.
I'll be all right.
Okay.
All right, let's press forward. Let's keep going. Okay, so we got some parallel lines here. So that's 47, which means x must be equal to 133. Use your calculator to work out. Now, you never get these questions anymore, because why would you? Why would you, instead of asking students to do something interesting on their calculator, why not just ask them to robotically type something in? Write down all the figures on your calculator display before you fall asleep to one significant figure, 40. Okay. try and power through this one. Pradeep wants to find out how much time people spend playing sport. Two things wrong. 0 to 1 hours versus 1 to 2 hours. What if 1 hour? And what if more than 4 hours? Always the same sort of things we're picking out here. Design a better question for
5. Yeah.
Say it again.
Or 2.5 hours.
Oh yeah, big gap in the middle there. Yeah, never even noticed that. So let's do this kind of thing. And then if h is greater than or equal to 3. Where h, I don't know why I'm using a, oh yeah, hours. H is hours spent playing sport. Now, this is another problem with this survey. Is this per day, per week, per month? Per week.
You probably want h greater than 3.
Yeah.
Oh no, that's fine. Yeah.
Okay, on the grid, draw that graph. And it's trying to trick us here because the scale on the x-axis does not match the scale on the y-axis. So we need a gradient of 3. We need to go through at -2. So we go along 1, we go up by 3. So it's going to look something like that. Not going to be tricked by the question. Mr. Weaver, how are you doing? Your garden is in the shape of a rectangle with 2 holes punched in it. He is going to spread fertilizer all over the grass though, and 1 box of fertilizer will cover 25 square meters of grass. Okay then. This is going to be a faffy sort of question, isn't it? So we've got that, which is 14.2. So the area of the rectangle is 14.2 times 9.5. So the area of the grass is 14.2 times 9.5. Subtract. Now we've got each of these are 1.9 meters in radius. So pi 1.9 squared, 2 of. So let's work out that now. I think that's enough. 14.2 times 9.5, subtract 2 pi 1.9 squared. That's 102.22. Box of fertilizer covers that much, so he needs 5 boxes to cover. Okay, potatoes costs £9 for a 12.5 kilogram bag. The same potatoes is 1.83 per 2.5 kilo bag. So farm is £9 per 12.5 kilograms. If we divide that by 5, then we'll get £1.80 per 2.5 kilograms, which is better than the 1.83 per 2.5 kilograms. So farm is better value, as long as you want to buy in that much bulk. You are only saving 3 pence per 2.5 kilograms, which isn't the biggest saving in the world. The scatter graph shows some information about 8 cars. For each car, it shows the engine size and the distance it travels on 1 litre of petrol. Negative. Strong negative, would we say? Sure. A different car of the same type has an engine size of 2.5 litres Estimate the distance traveled by the car. Okay, so quick line of best fit somewhere on there. That'll do. And then a 2.5 litre goes up to there, which is that's 10.8. Okay, rotate A 90 degrees clockwise about O. So it's gonna go to there, across 2, down 3, like that. And enlarge B by scale factor 3, center 1.2. So scale factor 3, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's gonna look something like that. Linda is going on holiday to the Czech Republic. She needs to change the money into Koruna. She can only change her money to 100 Koruna notes. She only wants to change up to £200. Right. So 200 quid is going to be 200 times 25.82. That's 5164. So we need a multiple of 100, so 51 notes. The integer values, so it could be -1, could be 0, could be 1, could be 2, could be 3. Solve that. 4x is less than 13, so x is less than 13 quarters. Usually nicer answers here, but whatever. The equation has a solution between 4. I'll use trial and improvement to find this solution. Wow, we do not do that anymore. So let's try 4.5 then. I think we took this off because it was so tedious. -6 lots of 4.5. 4.5 looks like it's way too small. Is 64.125. So I'm gonna go to 4.8. Let's try that. Ooh. It's quite a sensitive function.
Cubes.
Yeah. Oh my god. Let's try 4.
Oh, you got a 50-50 chance.
4.65. Let's do 4.65.
You only need it to 1 decimal place.
Yeah, so 4.64. Oh yeah, so 4.6. Is that what we would do?
Yeah, I think so.
It's going to be 4.6 and change, isn't it? But not as high as that, because that would round up to 73. Yeah, so 4.6 is our answer. Oh, so boring. So the probability that a biased dice will land on a 5 is 0.3. She's going to roll the dice 400 times, work out an estimate for the number of times the dice will land on 5. So it's just 400 times the relative frequency, which is 120. Here's James's favorite, mean from a grouped frequency. So we need the midpoints here: 5, 15, 25, 35, 45. So we estimate by doing 5 times 3 plus 15 times 8 plus 25 times 11 plus 35 times 9 plus 45 times 9. So 130, and then we divide by the total, which is 40. So divide by 40, and we get 28.25. Okay. P squared plus 5p subtract 36. Solve that. 5w minus 8 is equal to 12w plus 6. So 7w is equal to minus 14. So w is equal to minus 2. Factorize that. Difference of two squares. And simplify that. 3x to the power of 4, y to the power of 3 on 2. Henry is thinking about having a water meter. There are two ways he can pay for the water he uses. He uses an average of 180 litres a day. I love it how it has to clarify. He wants to pay as little as possible. You know, this is a question. This is like Hume, isn't it? You can't have an ought from an is. So you can't just assume that he ought to pay as little as possible. Yeah, we have to explicitly state it. So
You don't know what his motivation is.
well, no, not at all. So. Also, 180 litres of water in a day. That is Henry, slow down, mate. So,
One shower a day. You know what I mean?
180.
Not 5.
180 times 365. That's the amount of water that we're going to use in a year. That's the amount of cubic meters that is. That's how much it will cost us in pence. So let's work that out. So 180 times 365 over 1,000 times by 91.22. So that's a 59.93 pounds. And then he also gets charged the £28.20 divided by 100, and then we add on the £28.20, and that gives us 88.13. So the water meter looks a lot better. Usually ends up closer than that, doesn't it? But I don't see any error with what I've done there.
Oh, I think looks alright.
Okay, LMN is a right angle triangle. So cos x is equal to 6.4 on 9.6. So x shift cos 6.4 divided by 9.6 equals 48.2 degrees. Liam invests 6,200 for 3 years. 1.025 to the power of 3. See what I mean about these questions? It's just like basic trig question, basic compound interest question. There's no like problem solving or anything. So 6676.72. How much money? Pound sign. The diagram shows a quadrilateral ABCD. Okay, this looks like could be an interesting question. Calculate the length of CD. So this is your twin triangle problem. So let's call that X. So we work out X by doing root 16 squared minus 12 squared. That's not going to be anything nice. That's 4 root 7. So 4 root 7. And now to work out what this is. So sine 40 is equal to 4 root 7 over y. So y is equal to that over sine 40. 16.46. So to three significant figures, 16.5. Okay. Times 10 to the power 9 minus 4 times 10 to the power 8 over 8.5 times 10 to the power 9, 4 times 10 to the power 8. Okay, so that's some load of that. That's 48.8 times 10 to the minus 6, which is actually 4.8, well, 4.9 because it wants to do significant figures, times 10 to the minus 5. Okay, make t the subject of that formula. So 2d minus 2t minus 4t is equal to 7. Should have probably shoved it all on the other side. Let's do that. 2t plus 4t is equal to 2d minus 7. So t is equal to 2d minus 7 over what? Yeah, fine. Okay. Prove that that is a multiple of 8 for all integer values of n. Fine. So 4n squared plus 12n plus 9. Subtract 4n squared. Take 12n plus 9. So the 4n squared cancels with the 4n squared, the 9 cancels with the 9, and this results in 24n, which is equal to 8 times 3n, a multiple of 8. Give your solutions to 3 significant figures. So that's tipping us off that we're going to need to use the quad formula. So it is b minus b plus square root of b squared minus 4 times 3 times minus 2 all over 6. (1.72) and minus 0.387. Okay, fine. Max wants to take a random sample of students from his year group. Chosen everyone is equally likely to be chosen. Describe a method, random number generator, I guess. The table below shows the numbers of students in 5 year groups at a school. Lisa takes a stratified sample of 100 students. Right, so how many students do we got? We've got that many students. So we need to do 100 over 1140 times. So let's do, we just want to work out the number of year 9 students. So times 239. 21. Calculate the area. So to calculate the area, we need, let's do that. So x over sine 49 is equal to 8.7 over sine 64. So x 8.7 sine 49 over sine 64, 7.305. Okay, now we know what that angle is. So it's 180 take 49 take 64, that's 67. So the area is half 7.305, 8.7 sine 67. Three figures. Carolyn has 20 biscuits in a tin. So oh god, struggling. Work out the probability that the 2 biscuits were not of the same type. Well, we could have chosen a plain one first, and then a non-plain second. Or we could have done a chocolate followed by something non-chocolate. Or we could have done a ginger followed by a non-ginger. Okay. OAB is a triangle. OA is A, OB is B. Find AB in terms of A and B, so it's minus A plus B. P is the point on AB such that AP to PB is 3 to 1. Find OP in its simplest form. So OA plus 3/4 of AB is what I'll do. So that's A plus 3/4 minus A plus B. So that's 1/4 of A plus 3/4 B. That makes sense. You've got 1/4 of A, and then only 3. Yeah, I reckon that'll give you to P. Seems right. And that's the end of the paper.
Nicely done. 26 questions is quite a lot.
Well, it's the GCSE, isn't it?
Yeah.
It's about
Yeah. That's
usually
a lot of questions.
yeah, usually around I think 25 to 30 sort of questions. Oh, I just feel pants.
Breath, man. Keep going.
Yeah, give me a minute.
How many you got? You got 4 to go. What's next? Which one are you doing next?
Well, I've got the core 3, the core 4, and I've got the GCSEs. So
Yeah. Which ones have you got them in order? Like, what's the next one? Core 3?
I should probably get those out of the way. I should probably get the
You've done a couple easy ones. Do a hard one, then do a couple of easy ones, and then finish on your favorite. Yeah.
Well, my favorite was probably the degree paper that we did and spent ages talking about. So
But you did that one at the right time.
yeah. I don't regret any of the order that I've done them in. I just regret. You know what? I regret nothing. I just wish I didn't feel so bad. Thanks everyone for the words of encouragement. Give me a minute. I'll be back in a sec.
Hey, Ollie, how you doing? 3, I really liked Core 3 as a paper.
Just loads of calculus here.
Yes.
So yeah, I don't know. I don't really know what else is on there. You don't do ODs until core 4. Honestly, all I remember from it is just a bunch of calculus, and it's all of the like. That's what you do by parts. It's what you do by substitution. It's where you do natural logs, exponential functions, all that sort of thing. So let's just get on with it. So
have you done a Core 3 paper?
No.
Today?
No.
Okay. This is the first one.
Yeah, because I'm on the old spec now. So I've done. I did a whole bunch of A-level papers, and a further maths paper. So everything that's on Core 3 came up in those papers. I imagine, but come on. So. Express that as a fraction in its simplest form. So 3x plus 2 over 2x plus 2, 2x minus 2, minus 2, 3x plus 1. Yeah. Wow, okay, what an ugly question to start off with. So we've got 3x plus 2, 3x plus 1 minus 2, 2x plus 2, 2x minus 2, all over 2x plus 2, 2x minus 2, 3x plus 1. And it's going to want us to expand and simplify that top, so to see if any more cancellation happens. So 6x plus 3x, 9x plus 2 minus 2, lots of, so we're re-expanding this all over the denominator. So that will cancel with that. So we get 18x plus 4 plus 8 plus 12, which is 6, 3x plus 2. So not even any cancellation there.
You sure? No, that's 3x minus 2.
I think this is just it. Oh, hang on. I've done it. I've done all this wrong. So this is a 3x. Wow, that's really weird. So that does cancel with that. So it's 6 over 3x minus 2, 3x plus 1. Okay, fine. Okay. Iteration. Come on. So show that equals 0 can be written as that. Okay. So reading ahead, it wants me to pull x squared out of here, so x plus 3, and then it wants me to pull a 4 out of there, so that's x minus 3 is equal to 0. So x squared, x plus 3 is equal to 3 minus x, divide by the x plus 3, and then root it. So that's fine. And then use that iteration formula. So iteration, now the domain of the GCSE, but old A-level still has some questions. So 3 minus that over 3 plus that. So x2 is 1.41. X3 is, oh sorry, that's x1, that's x2, because x0 was 1. 1.20, and x3 is 1.31. The root of f of x is 0 is a. By choosing a suitable interval, prove that alpha is that. 2, 3 decimal places. Okay, so 1.2715 and 1.2725. Yeah, so 1.2715. So if I do that cubed plus that, I get minus 0.008. Yeah, I get 0.008. So change in sign. So alpha lives between those.
So, by the intermediate value theorem.
Yeah, we are using the. It is a continuous function, so it does apply. But yeah, you don't have to state that at this stage.
I mean, throw by the gluing lemma in there as well. Why not? Like,
yeah.
No one knew what it was.
So, x coordinate at the turning point of C. Okay, so let's just go ahead and differentiate this thing. We get e to the x root 3 times 3 cos 3x plus root 3 e to the x root 3 sine 3x. If that equals 0, then let's pull out that x root 3. So 3 cos 3x plus root 3 sine 3x. So can't be 0. So this equals 0. So this means that lost my headphone there. So this means that what does it mean? Root 3 sine 3x is equal to minus 3 cos 3x. So tan 3x is equal to minus 3 on root 3, or if we prefer, minus root 3 on 3, which is minus root 3. So that means that tan x is equal to arctan of root 3 minus root 3. So minus 60. It also equals that, because we want the x coordinate of the turning point for which x is greater than 0. Give your answer as a multiple.
You in degrees or radians here?
Oh yeah, good point. So okay, so arctan of minus root 3, we get minus 1/3 of pi, so this is 2/3 of pi. And so x is 2/9 of pi. Find an equation of the normal to see where at the point where x equals 0. Okay, so we want that. So we're going to find the gradient there by substituting in x equals 0 into our derivative. So if we put 0 into here, that term dies, that term becomes 1. So it's 3, which means the equation of the it will be y equals minus 1/3 x, I think. Because that whole becomes 1, that becomes 0, that becomes 1, so it's 3, yeah, and it goes through the origin. So, seems to be the case. Okay. Ooh, okay, so some modular functions here. So on this one, we're gonna have that. So that's still P, and that's still Q. For the second one, we are gonna have, so you're making all the x values positive and then evaluating. So I guess it's just gonna look like that. That is still Q. More like that, really, isn't it? Like a dinner tray. Yeah. And now the third one. So squish the whole thing up. So it looks like that. And then stretch it that way. So it's going to be 0, 10 minus half 0. Alright, nice. Okay, oh geez, how many of these have I done in the last 24 hours? Honestly, I think I've juggled cosec squared around more times than I can, more times than I care to admit. So in terms of sine theta and cos theta, so this is 4 over sine squared 2 theta minus 1 over sine squared theta. I'm supposing that it wants me to get rid of that double angle. Well, I mean, that is in terms of, well, it's not in terms of sine theta, is it? So sine squared 2 theta is equal to sine of 2 theta squared, which is equal to 2 sine theta cos theta squared, which is equal to 4 sine squared theta cos squared theta. So this is equal to 4 over 4 sine squared theta cos squared theta. 4's cancel, 1 minus 1 sine squared theta. So if we really wanted to, we could do 1 minus cos squared theta over sine squared theta cos squared theta, and in fact that is equal to sine squared theta over sine squared theta cos squared theta, which is 1 over cos squared theta. Okay, Oh, I've actually answered this part here as well, because that is equal to sec squared theta. I just genuinely, when it says in terms of sine theta and cos theta, are you supposed to stop there? Like, as soon as you get the coses and sines involved, it's hard to know like where they actually want you to stop that process. So hence or otherwise, solve that. So we've done all the hard work, and we've got that 1 over cos squared theta is equal to 4. So cos theta is equal to 2 or minus 2. No, it doesn't. It's equal to a half or minus a half, right? Because flippy flip, rooty root, that looks about right. So theta is equal to inverse cos of a half is pi by 3.
Yep.
We're only going between here and pi, so I think that's the only angle that we're going to get. That's going to give us 1 as well. So let's do the minus half case, and 2/3 of pi. I think they're the only answers that we get.
Right. Yep, and that makes sense.
Functions. Okay, state the range of f. So f of x is greater than 2. Find f g of x. So f of log x, that is e to the log x plus 2, which is just x plus 2. Find the exact value of x for which that happens. Okay, so e to the 2x plus 3 plus 2 is equal to 6. So e to the 2x plus 3 is equal to 4. So log 4 is equal to 2x plus 3. So x is equal to half log 4 minus 3. Again, I'm not sure what form it wants it in, but it says the exact value, so it's going to be something like that, isn't it? Find the inverse function of f stating its domain. So it's going to be log of x minus 2. And its domain, well, we have to have that x minus 2 is greater than 0, so x is greater than 2 is the domain. Okay, on the same axes, sketch the curves y equals f of x and y equals f inverse of x. Okay, so the exponential function will look like that, and it goes through there at 3, does it? When x is 0, 1 plus 2, yep. And then the inverse, you reflect it looking like that, going through at 3.
Bread and butter question now. Bread and butter question now. Just differentiate stuff.
Yeah. Yeah. So, x to the power half, 3 over 3x. It's that. I'm not even going to bother tidying it up. That's an exercise left to student.
Oh man, if you wrote that in an exam, left to marker,
Yeah.
I think you're fine with that.
0 for the paper. So I'm going to do the product rule in this one just because I'm feeling like if I do the quotient rule, I'm going to end up with a 2x minus 1 to the power of 10 as a denominator, which is just horrible. So let's do the product rule. So that's minus 5, 2x minus 1 to the power of minus 6. I mean, that's bad enough. Times 2 plus 2x minus 1 to the minus 5 times minus 10. And it does want me to give the answer in its simplest form, unfortunately. So, no weaseling out of this one. We've got 1 minus 10x times minus 10 all over 2x minus 1 to the power 6 plus, well, we've got minus 10 over 2x minus 1 to the power of 5. Okay, so this is, we need to times this by 2x minus 1 and make that into a 6 so that we can subtract them. So we get 100x minus 10 subtract 20x plus 10. They die, so we end up with 80x over 2x minus 1 to the power 6. Okay. Now, I did a question just like this earlier on. And what happened was...
You have a formula book for this?
No, don't need it.
You just have to remember how to differentiate tan.
Well, that's sec squared it goes to, yeah. But that's fine. I mean, the approach that I thought we could take is to do that and then differentiate that, because that's like a standard, differentiating inverse tan is a standard thing. But I couldn't figure out how to do it that way. So I ended up with the implicit differentiation way is equal to 6 sec squared 2y dy by dx. Now sec squared of 2y is equal to, now I think it's 1 plus tan squared. I always forget. I always need to do it from scratch every time. So if I want to get sec involved, I need to divide through by cos. So I get tan squared plus 1 is equal to sec squared. Yeah, so this is 1 is equal to 6 tan squared 2y plus 1 dy by dx. And tan 2y squared is equal to x squared on 9. Isn't it? Yeah. Now we need to add 1 to this. And then we times it by 6. Right, well, whatever. It's 6. Okay, so 9 over 6 is equal to x squared plus 9 dy by dx. Therefore, dy by dx is equal to 3 over 2 x squared plus 9. So let's go with that.
Wait, what? Yeah, okay. Yep. Checks out.
Okay. It's an old paper, but it checks out. Morning, Kenny. Thanks for your message. Some of the classic core 3. So we did our A levels together, me and Kenny. So, oh god, I just feel so bad. I'm really starting to hate this. How many more questions?
You can do it. Where are we? We're on question 8 of...
8 of 8.
8 of 8. Oh, you've cracked through it. Well, I think you started this at about 8 o'clock.
Yeah, that's pretty good going, actually. It usually takes me 50 minutes to do these.
Oh, half an hour to go.
Come on. Well, yeah, looking at this question, it could be a bit of a meal.
This is a beast.
So...
12 marks.
So... I had one like this before. So cos 2x plus alpha is cos 2x cos alpha minus sine 2x sine alpha. So R. So we are saying that R cos alpha is equal to 7. And we are saying that R sine alpha is equal to 24. So that means that tan alpha is equal to 24 on 7. So alpha is equal to, make sure we're in radians. So inverse tan of 24 on 7. Alpha is 1.287. Now, we had a trick before where we did r squared cos squared alpha plus...
Yeah, given that the question is in degrees, do they want it in degrees?
Oh, for goodness sake. I get it wrong every time. Yeah, thanks for spotting that. 73.7 degrees. So we did this trick before. So this is equal to 49 plus 24 squared. Yes, good. Because now r squared is cos squared alpha plus sine squared alpha, which is of course 1. Now we get r squared is equal to that, which is 625. So r is equal to 25. So it's nice. Okay, so we know now f of x is equal to 25 cos 2x plus 73.7. Hence, solve the equation. So, we've done the hard work to get the 25 cos 2x plus 73.7 is equal to 12.5. So, in other words, equals half. So, in other words, shift cos of half is 60. Okay, 60. So we've got 2x plus 73.7 is equal to 60. And we've got half. So that's 60. So 300 is the other option. In fact, I might just do another one on there, 420, just to see if it actually gives it in range. So 60 is bad because when we subtract 73.7, it's going to go negative. 300 subtract 73.7 is that, divided by 2 is that. So x equals 113.15, that's one solution. 420 minus 73.7 is that, divided by 2 is that. Ooh, yes, and it just sneaks into the range, so I'm glad I did that. Thought I was wasting my time there, to be honest, but it's just in range. Okay. Wants them to one decimal place, isn't it? So 113.2, 173.2. Okay. Last bit. Express all of that nonsense in that form. Come on. So the reason I've done that is because, oh god, just drop my pen. So that is equal to sine 2x. Now how do I get the cos 2x involved? So cos 2x is cos squared x minus sine squared x, which is cos squared x minus 1 minus cos squared x is 2 cos squared x minus 1 . So cos 2x plus 1 is equal to 2 cos squared x. So 14 cos squared x is equal to 7 cos 2x plus 7. So that there is the 7 cos 2x plus 7. So I've got 7 cos 2x plus 7 minus 24 sine 2x. Right, what folder does it actually want it to be in? Pretty much that. Yeah, so A is 7, B is minus 24, and C is 7. That'll do. Hence, using your answers to part A and part C, deduce the maximum value of that. Oh, my back. So right. So yes, I've got it. So 14 cos squared x minus 48 sine x cos x, we demonstrated is what? property with this. We showed that that is equal to 7 cos 2x minus 24 sine 2x plus 7. Now this is a really, really good green light, because this tells me exactly that I'm on the right lines, because that is f of x as seen in question A. So I'm trusting that my coefficients are correct, because it's turned out so nicely here. So we know that this is going to be, what was it, 25 cos 2x plus alpha, which is like 73.7 or something, plus 7. And the maximum that this could be is 25 plus 7, which is 32. Because the biggest cos value is 1. That's the absolute biggest it could be. Okay, so that was all right, wasn't it?
Yeah, like that. Yeah, that last question was pretty good. Actually, fairly straightforward.
Yeah.
Once you once you figure out what you've got to do. There we are.
As always.
All right. Yeah. Well, yeah. Core 4 next, I think. Is that right?
Yeah. Yeah.
Very good. Get up. Get stretched.
I might make a cup of tea.
Yeah, a cup of tea is a good idea. Maybe with a biscuit too. You deserve it.
Thanks, Dan. Let's change that. Exam 22 of 24, core 4. Oh, come on. End is nigh. I'll be back in a moment.
To anyone watching the stream, let's give some extra encouragement to Alex. He's really starting to feel it. Hour number, what is he up to? Hour number 20, 21. Hour number 21. He's on.
All right. God, I'm freezing. You there?
Yes, yeah, I'm here. Oh gosh, I was talking to the audience and I put myself on mute. So everything that I just said is completely wasted.
Amazing.
Oh. Yeah.
So, 8 questions. That seems reasonable. The last of the A-level papers. Come on. Okay. Like I haven't done enough partial fractions today, here's just one more to see us home. So, we have 1 is equal to a 3x minus 1 all squared plus bx 3x minus 1 plus cx. Okay, so 1 is equal to a 9x squared minus 6x plus 1 plus 3bx squared minus bx. Usually like to leave them unexpanded actually. I don't like that I've done that. Okay, so 1 therefore is equal to a... Okay, that's easy. We know that 0 is equal to minus 6a minus b plus c. And we know that a is 1 actually, so this is telling us that c is equal to 6 is equal to c minus b, and we know 0 is equal to 9a plus 3b. So 9 plus 3b tells us b is equal to minus 3, and so c minus 3 is equal to 6, so 6 is equal to c plus 3, c is equal to 3. So there we go. Hence find the integral of f of x. Boy, did I struggle with this last time. So come on, don't screw it up. 1 over x plus negative 3 over 3x minus 1 plus 3 over 3x minus 1 squared. Integral of dx. So, it's integral of 1 over x dx minus the integral of 3 over 3x minus 1 dx plus the integral 3 times the integral 3x minus 1 to the power minus 2. Okay. So, this is log x subtract log 3x minus 1 plus 3, so it's 3x to the power minus 1 to the minus 1 all over minus 3. Okay, and hence find between 2 and 3, sorry, between 1 and 2. So log 2 minus log 5 plus, well, that's just minus 3 times 2 subtract 1 is 1 over 5. Subtract log 1 subtract log 2, subtract 1 over 2. I think that's right. Log 1 is 0, so I get 2 log 2, subtract log 5, so subtract a fifth plus a half. Let's make that squared. So this is log 4/5 plus 3/10. Are they rational constants? Well, they're just constants, so I'm going to suppose that that's all fine. Well, quite a heavy question to start with, that, wasn't it? Okay, so a metal cube which is expanding uniformly as it is heated. Okay, so V is equal to x cubed, therefore dv by dx is equal to 3x squared as required. Given that the volume V increases at a constant rate, so dv by dt is equal to 0.048. Find dx by dt. So dx by dt will be dx by dt dv. So this is 1 over 3x squared times 0.048.
Mm-hmm.
0.048 divided by 3. Pretty easy just to keep it like that. So when x is 8, I get 0.048 over 3 times 8 squared. Is 1 over 4,000. Or 0.0025. Find the rate of increase of the total surface area of the cube. A is equal to 6x squared dA by dx. Oh wait, what do we actually want? We actually want the rate of increase. So we want dA by dt. God, my eyes are just going really funny.
Get through. How is your tea?
It's delicious.
What brand of tea do you normally go for?
I'm a bit of a snob with tea, so I go to like a specialist tea place, Bird and Blend. It's called. It's very very nice. It's
Other tea shops are available, just in case anyone is wondering.
It's not the BBC then. Oh, God, I feel so bad. I just want it to end.
All right, let's keep going. Number 3.
Come on. Binomial expansion. How many times have I done this? I need more. If I ever do this again, I need more variety in the papers that I'm doing, because honestly, I don't want to do that anymore. So 9 minus 4x to the power of minus 1/2, and it wants up to including the term x cubed. So it's quite a chunky question. So let's pull 9 out. So 9 to the minus half. What's that? 3. So this is 3. Okay, binomial expansion for the last time. 1 plus minus 1/2. Calculator. So I put add times. Neither didn't look right. 2 9s, that looks more like it. Didn't take that 2 factorial into account. Okay. So this is just a slight modification. This is we just changed these to all positive. Okay, and h of x. Change instead of 4 there, it's going to be 8 there. So
Are you sure about these?
reasonably.
Eight over 9x.
Yeah, pretty sure that's right. So it's doubling coefficient to the power of whatever it is. Okay,
Yeah.
solve.
That's a good suggestion, Kenny. If you do this again, Alex, do some papers from the US or from some other country.
Yeah, I think maybe Lee suggested this a couple of years ago. Well, last year when I was gearing up for the first one. It's such a good idea. I'd love to do it. The papers are surprisingly difficult to find, especially abroad. Like, you know, to get them written in English and things like that. But I would love to try and do it. Right, we've got an ODE here. So integral of y dy is equal to 3 times the integral of sec squared x dx. So the y squared on 2 is equal to 3 tan x plus c. Okay, and we're told that 2 is equal to 3. Tan of pi by 4 is what? Oh, come on, radians. 1. So plus c, so c is minus 1. So y squared on 2 is equal to 3 tan x minus 1.
Very good.
Yeah, weirdly straightforward. That equation. Okay, so it's more. Quite a lot of implicit differentiation. It always used to be one of those like niche ideas, but there's been a lot of it tonight. And it's with product rule. B equals 0 implies so. Why is this worth 7 marks? That's my only concern. suppose when we actually go and do this, might be awkward. Yeah, it looks a bit awkward. 432 plus 27x squared minus 54x is equal to 0. Can we divide that by 27? Yes, we can. Nope. Seems like not a lot of work for 7 marks though, that's my only concern. You know? I don't need to do anything.
Yeah, is that x squared? Should that be x squared? 27x squared?
Where?
We're at 432 plus 27x to the 4.
No, don't think so. It's an x squared there, innit? And then y is 3. Yeah?
No.
We're just putting y into here. So 9x squared y, where y is 3. It's 27x squared. I mean, I'm happy with this. So.
The mark scheme's not.
Oh really?
Yeah. 18 minus 6xy equals 0. Using x equals 3 over y.
Oh, there's an x here. So,
Yeah.
there we go. There we go. Oh, you've just ruined everything. I thought I had this question finished, but no, it's not. So, I get xy is equal to 3. Oh, okay. Bad. So, fine. Let's get some paper. So we get xy is equal to 3. Yeah, I had a feeling about that. So xy is equal to 3. So y equals 3 over x. So we have 16 3 over x cubed plus 9x squared times 3 over x minus 54 x is equal to 0. So we get x is 2. Okay. So now or -2, I suppose. The only difference being that we get that.
Yep. Now work out the y.
Mm-hmm. Oh, awkward doing it. So
Oh, no, because you've already got the x, so you can just put it into your y equals 3 of x.
So y equals 3 on 2, or 1.5, and y equals -1.5 when x is -2. Okay, there we have it. There we have it. So they're the coordinates.
That feels better as well.
Yeah, it feels like I did more work to earn those 7 marks. Right, okay. So, looks like a parametric curve. So dx by dt is equal to 2√3 cos 2t. dy by dt is equal to, so this is 4 cos t squared. So this is 4 2 cos t to the power of 1 times minus sine t. So dy by dx is equal to dy by dx dt dt. So dy by dt is -8 sine t cos t over 2√3 cos 2t. -8 sine cos, that's -4 2 sine cos, so that's -4 sine 2t, 2√3 cos 2t, -4 on 2√3 tan 2t, and it wants us to rationalize, so -4√3 over 6 tan 2t, which is -2/3 √3 tan 2t. Oh my god, I can't. I'm finding it so hard.
Hey, you're blasting through it.
I know, but the amount of focus I'm having to put in, it's just like,
right. Yeah.
I keep falling asleep. I keep closing my eyes for a second too long, and I wake up and I'm like,
yeah, I get that. But you're doing well. You've got this is the hardest paper that you have left.
yeah.
And it's core 4.
I never thought I'd struggle to get this.
And you're almost done, I think, on this as well, actually. You've only got like a question and a bit to go.
Two questions.
Two questions.
Two questions
Yeah.
can change it. Should need a bit of paper here. Find the equation to the tangent where t equals pi by 3. So the gradient is dy by dx is equal to, so pi by 3 minus 2/3 root 3 tan is 2. So it's going to be y equals 2x plus c. Now we just need to know what the x and y values are at that point. So let's do pi by 3 again. So root 3 sine 2 of those is 3 over 2. So x is 3 over 2. Let's go for pi by 3 again. 4 cos ans squared is 1. So 1 is equal to 3 plus c. c is equal to minus 2. y equals 2x minus 2. Find a Cartesian equation of c. How the hell do you do that? Usually we're finding t in terms of one of the variables and shoving it into the other, but
Yes.
this isn't.
That's right.
Yeah, this isn't.
Yeah.
So what do we do here? What do we do? Well, I can sort that double angle out.
Mhm. Mm-hmm. No, I think that's fine. Yep. Yep.
Yeah, I mean, yeah, we can start faffing around with this.
Yeah, no, but you've got it. You've got an equation.
Yeah,
You've
yeah,
got a
yeah.
Cartesian equation for C. You're done.
So I'm happy with that as well.
Mm.
It's just I think that's an ellipse, isn't it? So we could complete the square and stuff to find where the center is and all of that kind of stuff. So
Yeah, but you want what? Yeah, yeah, yeah. But that's not what they're asking you for.
no, I'm not gonna go above and beyond.
Thanks.
Oh my
Right.
God, the trapezium rule again! I can't believe this. These papers just really have it out for me tonight, last night, and yesterday.
No, no,
and,
no,
and
no.
today.
You still you are still in yesterday.
Oh dear. I hate it. 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 God, I mean, if anything's going to put me to sleep, it's going to be this. So, using the trapezium rule with 3 strips of equal width. So we're going to do strip, 2, 3. Right, so come on then. X, 1, 2, 3, 4. Right. One to the power of a half log 2 of 1. And then we have to find the integral anyway. Ugh. So x to the power of a half log 2x dx. This looks by partsy, doesn't it? So let's let's do u is log 2x. That means du is 1 over x. It's 2 over 2x. dv v yeah, this is good. So uv
We're good.
just okay. It's wrong.
Wait, say again?
It's wrong.
Right, so,
That's wrong for a start. So minus 32 on 9 plus 4 nines is minus 28 on 9. But I'm nowhere near fixing the damage. It's definitely
you're in B. Should the second line be divided by 3? You should have, because yeah, it's 2/3, because you got to divide by the power, so it's 2/3 x 3/2, so 3/2. Are you with me?
no.
The second line where you've got equals 2x to the 3/2. That should be 2/3x to the 3/2.
Here?
That line, yes.
Yeah, but I did some cancellation here, didn't I?
No, your first term.
Oh, this.
Yeah.
Ah. Yeah, because it's UV. So, yeah, I need an over 3 there, don't I? So, yeah. Okay. So 16 log 8 on 3 take, and that's 2, so that's 48 log 2 on 3 take. Yes, it's 47 on 3 log 2. It just does not, it's not right.
Yeah, no, you're right. It is right. Minus 28/9.
Yeah, I got the minus 28 over 9. Yeah. So that's right.
Yeah.
Oh my God.
Yeah. That is it. It's not a very pretty answer.
Christ. Right. Come on. Last question of this bloody paper. Right. They love these IJs and Ks, don't they? Why? What was ever wrong with column vectors? You know what I mean? Point A has position vector that. Point B has position vector that. So vector AB. I feel like I've done loads of these tonight as well. I'm gonna do it in column form because why the hell not? It's gonna be -2, 1, 1. B. Find the vector equation for line L. Now, I haven't done much of this tonight, actually. So, tonight, I keep saying tonight, don't I? But, you know... Oh, Jacob also spotted that, I've just seen that he spotted that my first term was erroneous. So, thanks for pointing that out. I'm sorry I didn't see the comment. I need to keep checking those. Because this is the stage where I just completely lose it.
Pull together. Yeah, that's all banded together. Let's
So line
exam by community.
Line L, we'll start from A, and then we're doing increments of the direction vector. So lambda real, and And now position C has vector, point C has position vector that. The point P lies on L. Given that CP is perpendicular to... Oh, what is going on? So, right, quick sketch. Line L. P lies on L. And we've got our AB somewhere along here. Not necessarily like that. And then CP is perpendicular to L. Right, so how do you do these again? So we know P lies on L. So that means that P equals 10 minus 2 lambda, 2 plus lambda, 3 plus lambda for some real lambda. So that's what P is. And we also know if we find out what CP is, I think I know what to do. I'm just making sure I'm doing it right. Yeah. So what is C then? It's 3, 12, 3. So C to P is gonna be it's like that, isn't it? So it's 7 take 2 lambda minus 10 plus lambda. Is that right? So to get from, if I add that to that, I should get that. That to that, I should get that. That. Yes, that's to that. I should get that. Okay, so CP. And given that it's perpendicular, we know that this will dot with the direction vector to make 0, right? So minus 14 plus 4 lambda minus 10 plus lambda is equal to 0. So 6 lambda is equal to 24, so lambda equals 4. That's nice. So now find the position vector of the point P. Well, we defined it as such. So P is equal to 2, 6, 7. Okay, done. Done.
Just want to take a pause here and thank Vicky, Amy, Jacob, and Johnny for donating. That's through this paper gave a huge amount of donations. Probably just as people are waking up.
Just as people are starting to feel sorry for me.
Spurring you along. Yeah.
Thank you so much, everybody. Thank you so much. Really, really appreciate it. Kill me now, Dan. Just kill me, all right?
We can't do that yet. No, because you've got 2 papers. I'll kill you in 2 papers. How about that? Deal?
All right. Okay.
All right. Very good.
I'll be back in a sec.
Now, one thing that I do keep an eye on are these breaks, and if I think at this point of the evening or the day, um, if Alex takes any longer than sort of 3 or 4 minutes, I will give him a ring, because he might have fallen asleep on the toilet.
Just dropping in to keep you company down during the
Thank you
little
very
pause.
much, James.
Um,
Because I've
that's very wise.
yeah, 'cause I don't know about you. I've had one of these, super late night things or challenges where you've had to stay up, and I've fallen asleep. Like had these little micro sleeps
Well,
somewhere.
I'll be honest that I don't, as you're aware, I become pretty useless after about 9 o'clock at night, so I've never done one of these all nicers. But yeah, I have to say as well, just while he's not listening, last night he's not had a protractor through this whole thing.
Right, yeah.
So last night I was like, oh, I'm gonna order him on Amazon Prime a protractor,
Oh
and
no.
I know it is on its way. And last night I thought, oh, that's going to be funny, but I think he's potentially going to be quite cross when this protractor arrives now.
Well, the thing is, because he'll be asleep.
It will. Well, no, because I got the Prime before 1 p.m.
Yeah, no, he'll be asleep.
You reckon? I don't
Oh,
know.
yeah.
I think it's going to come in the next hour or two. But anyway, I'll shut up
Oh,
about
yeah.
that now.
Oh, very good. Well, we've been joined by James here. James is here to keep us company.
Just thought I'd pop along and say hi.
And happy birthday, James.
Thank you.
Once again,
yes,
you're
of
on your
course.
birthday.
31.
For 2 years running, you've
That's amazing.
No place I'd rather be.
Okay, if you say so. If you say so. Right, come on. How quickly can we do these GCSE papers? New GCSE. Yeah, and just to reiterate, thanks so much, Amy, Vicky, Jacob, and Johnny. All very much appreciated. So, we're almost at the 1,000, aren't we? 2,000 was a bit ambitious for this one, wasn't it? But
yeah, Amy as well, giving a very very pi related amount there as well.
Yeah, love it.
Always appreciate that.
Always appreciate pi. Are you on Team Pi, Dan, or are you on Team Tau?
Honestly, it really doesn't matter.
Well, no,
because
of course it doesn't matter.
Yeah,
that wasn't the question I asked.
I'm a total neutral. I'm agnostic, or not agnostic. I mean, I believe in it, but I'm totally neutral to totally accepting of anyone's choice in how they choose to measure their circles.
See, neutrals. That's where the real enemy. You don't know where you stand with neutrals.
If someone uses tau, I will use tau. If someone uses pi, I will continue to use pi. It's just whatever makes it easier for the reader.
Oh my goodness. Anyway, we could have this is a religious war that could continue for far too long, and this gentleman needs to do these GCSE papers. So
okay, so come on, let's do it. 3n minus 2. Show that. So that's 5/3 times 15 quarters. This looks very familiar, actually. Have I not already done this? Or have I just done so many papers that are all starting to blur together? Well, anyway, that's 5 on 1, so 25 on 4. In other words, that is 8 3/4, isn't it? 8, 16, 24. No, it isn't. What have I done wrong here? Oh, come on. What is going on? 2 1/3 is not 5/3, you moron. Come on, don't rush it. Don't rush it. I'm still happy that that's 15 quarters. So 5, that's 35 on 4. This looks more promising. That's 32 plus 3 on 4. So that is indeed 8 3/4. Come on, I can do better than this. Okay, well, we have got the positive cubic, we've got the negative cubic, we've got the quadratic, we've got the reciprocal. Okay, the diagram shows 4 triangles. 2 of these triangles are congruent. Right. Smells like it's these two. So, this is actually the non-calc paper, so let's put that calculator away. So 45 plus 55 is 100, so that's 80. So we've got the 55 here. Yeah, so I'm happy that A and D. Yeah, you've got angle, side angle there. Sean, here he is again. Here's Sean. So Sean has featured in quite a lot of the questions this evening. I'm saying this evening like it isn't whatever time it is, I don't even know, 9:42. He pays £10 for 24 chocolate bars. He sells all 24 chocolate bars for £12. So that means he's made £2. Out of the £10 is a 20% profit. Okay, ADC is a triangle, my favorite. EBC, ADC, work out the angle EAB. Well, that must be 32 because it's co-interior. And then 63 plus 32 is 95, so 85 for DHC. Oh, a stem and leaf diagram. Not my favorite. So, we've got the girls here. We've got the boys in the stem and leaf. Compare the distribution. So there's 15 boys, so 1, 2, 3, 4, 5, 6, 7, that's the median, 164. The lower quartile, 1, 2, 3, 4, 5, so that one, then that one, then that one, so that one. Yep, 1, 2, 3. Yep, 1, 2, 3. Yep. So the median. Oh, it's comparing the least height and the greatest height. That's unusual. So the least is 158. You usually compare the upper quartile and lower quartile, actually. And then the greatest height is 182. So the girls taller on average. What's the range of that? 20. And what's the range of that? 24. Boys more varied. Let's say that. If you want to weigh in, James, you can wait. So,
yeah, I'm gonna write some stuff in the chat about this.
Okay, yeah. Well, you have a lot to say about stem and leaf diagrams, but this is point. No, it isn't. They're just terrible, aren't they? And I won't be dissuaded. Okay, the prism has a height of 3, it has a volume of 18. The pressure on the floor due to the prism is 75 newtons. Work out the force. So the surface area of that is 6. So force is pressure times the area. So the pressure is 75, the area is 6. So all in all, we have 450 newtons. Write these numbers in order of size. So 1, 2, 3, 4. That's 6.72 times 10 to the minus 4. So smallest is that one. I'm going to say first smallest, and then that one, and then that one, and then that one. Okay, given that and given that, find that. So this is saying that A to B is equal to 2 to 5, and we've got B to C is equal to 3 to 4. So we've got A to B. So okay, so 2 to 5, 3 to 4. Let's do a bit of timesing. So 6 to 15, 15 to 20. So 6 to 15 to 20. Find the value of that. Well, it'll be 3 times 10 squared, which is 300. The value of that is 1 over 8, and the value of that is a power of 3. Well, that's 3n over 3 squared to the power of n minus 1, so 3n over 3, 2n minus 2, so it's 3 to the power of n, subtract 2n minus 2, which is 3 to the power of 2 minus n. Not as easy as they usually are. Cumulative frequency. Are you joking? 5, 15, 35, 55, 70, 80, which is right. On the grid opposite, draw. Oh, Jesus, I've done so many of these. So that, that 450 is 70, and then 80. Ooh, nice S curve there. Okay, so we're done with that. 60% of this group have a weekly wage of £360 or less. Is one correct? Let's find out. So £360 or less. So we want about there. So I don't think it's looking good for one. So I would say 39 are 360 or less, but 39 out of the 80 is approximately 50%, which is much less than 60%. So no, he is wrong, I would say. Okay. Yes, the old familiar. So rho equals mass over volume. Okay, so volume of A is 70 by yes, it's the volume. Sorry, the volume is mass over density, so it's 1400 divided by 70, which is 20. The volume of B is the Okay, we know the volume of B is 30. The mass of B is what we don't know. So that's 280 times 30. So 28 times 3 is 60 plus 24, 84. Bang a couple of zeros on there. Okay, so the density of C is the total mass, so 1400 plus 8400, which is 9800, divided by the total of volume, so that's 20 plus 30, so it's 9800 over 50, cancel a bit, and we get, what is that, come on, brain, just work it out. Come on, do it. It's that, I think. Can't believe I'm having to do this.
That looks about right. Mm-hmm. Yep.
Yeah, it is. Yeah.
Yeah.
196 kilograms per cubic meter.
Yep.
So, Sally plays 2 games against Martin. In each game, Sally could win, draw, or lose. In each game they play, the probability that Sally will win against Martin. Work out the probability Sally will win exactly one of the 2 games. So, we need that she does a win and then a not win. And then we want the probability that she does not win, followed by a win. So win is 0.3 times 0.7, and not win is 0.7 times 0.3. So this is 0.21, 0.21, 0.42. Straight line has that equation. Straight line L2 is perpendicular and passes through. So y minus 5 is equal to minus 1/3 x minus 9. So y is equal to minus 1/3 x plus 3 plus 5 plus 8. Okay. Shirley wants to find an estimate for the number of bees in her hive. On Monday, she catches 90 of the bees, puts a mark on each bee, and returns them to her hive. On Tuesday, she catches 120 of the bees. She finds that 20 of these bees have been marked. Work out an estimate for the number of bees in her hive. Okay. Okay, so out of the total number of bees, she catches 120 of them and finds out that 20 have already been marked. So that means approximately 20 out of every 120 have marks. In other words, 1 in every 6 have been marked, and she caught 90 of them. So 1/6 the number of bees is equal to 90. So the number of bees is about 540. James, what do you think about that question?
Oh, cool! I don't remember this ever being there. Like capture recapture, it's classic.
Yeah.
Thing, but it's really cool that they'd ask about this. This is awesome.
Do you agree with the answer?
I actually was not paying attention. I'm so sorry.
All right, great. Okay, well, yeah, because I'm not entirely confident about that, but yeah, 'cause this is actually a genuine technique that's used when you're trying to, I mean, bees, or when you're trying to estimate the population of, like, you know, of species of whatever. You can tag and you can iterate upon that as well. If you capture, recapture, and recapture again, it becomes more reliable, right?
Yeah.
So
No, I think what you've done is good. Yeah.
Okay, Shirley assumes that none of the marks have rubbed off between Monday and Tuesday. If Shirley's assumption is wrong, explain what effects this will have on your answer. So if some of the marks have gone, then the answer will be larger. Because if in fact we've said that a sixth of them have marks, but in fact if it was 90 plus some amount and then times by 6, then we would get a larger number.
No, it's the 20, right? No, hold on. It's the 20. So it's what it is saying is like, so she finds 20 marks on the 120 bees that she's caught, but some of those bees have had marks that have rubbed off.
Yes.
So it's the other way around. But yeah.
So if in fact, so she's saying 20 of them are marked, but it could be the case that it's actually that.
Yeah. Yeah. Yeah.
So only actually a quarter of them have been marked, which means we get a small answer. Yeah.
Oh, Jacob spotted it as well, so we're all on the same page.
Yeah, that's subtle, isn't it? Because my intuition said larger there. Yeah. I suppose you could take it to the extreme. Imagine if you marked all of them.
And then all the marks rubbed off.
And then all the marks, yeah.
Then
you'd expect to. Yeah. Okay. Sure. Yeah. Good spot. So make F the subject of this. Okay. So DF plus 3F is equal to 4D plus 3. So F is equal to... Oh, why do I try to do it all in my head? It always goes wrong. Minus 4D is equal to 3 minus 3F. So F D plus 3 is equal to 3 plus 4D. So it was right. 3 plus 4D over D plus 3. X is directly proportional to that. Y is increased by 44%. Okay. So now we go to, I feel like it's going to be a 20% increase. X goes to K 1.44, Y and root 1.44. Have we already had this question? Is 1.2 equals K times 1.2 times root Y. So a 20% increase. Okay, functions are as such. So g of 5 is, so when x is 5, we get 33. Find g f of 9. Well, f of 9 is 4 and g of 4 is 27. G inverse of 6. So I'm going to use my trick again here. So that equals something. G inverse of 6 is equal to g of a. So in other words, 6 is equal to g of a. So we want the value of that is equal to 6. In other words, 2a plus 1 equals 2. In other words, a is 1/2. Yeah, happy with that. Okay, so bodge the third. That's the question here. So 180. What's that? That's 2 times 2 times 45, which is 9 times 5. So this must be able to be written 2 times 3 squared times 5. Yeah, because it's 36 times 5, isn't it? So that's root. So that's 6 root 5 is root 180. So we've got 6 root 5, 4 root 5 upstairs, and then we've got a 5 root 5 minus 5, and then we need to rationalize this. So we get 5 root 5 plus 5, and 5 root 5 plus 5. Okay, so that is 100 plus 20 root 5 over 5 times 5 is 25 times 5 is 100 again. Whoa. 125. Surely. 5 times 5 is 25 times 5 is 125. Yep, everything else dies. And then we've got the minus 25 here. So this is equal to 1 plus root 5 over 5. And if I wanted to, I could check my answer here by doing this over 5 root 5 minus 5. And that is the same, isn't it? Yeah, 5. Yeah. Okay, so confident about that. DEF is a triangle. Okay. This is an interesting question. So FD is A and FE is B. Okay, so let's get our hands on PQ. So PQ is equal to PD plus DQ, and that is equal to half of A plus, now DQ is half of DE. This is half of A plus half of DE is minus A plus B. And this is looking good because I want the A's to disappear. I want it to be a multiple of B. So this is going to die and become half B. So in other words, PQ is a scalar multiple of FE, which equals B. Therefore, parallel. Okay. Ooh, this looks meaty. So, shape A is formed by removing a sector of a circle with radius 3x minus 1. Okay. Fine. And they have equal areas. Wow. Okay, so the radius of this, first of all, is 1 minus x. So area of B is equal to pi 1 minus x squared. Now the area of A is going to be, so the big circle, so 3x minus 1 plus 2x is 5x minus 1. So pi 5x minus 1 all squared over 8 because it's an eighth of the circle. subtract pi 3x minus 1 all squared over 8. And it's equal to pi 1 minus x squared. I think that's the setup. So cancels, cancels, cancels. So it's a whole bunch of expansion here. So we've got 25x squared minus 10x plus 1. Subtract 9x squared minus 6x plus 1 is equal to 8. 1 take 2x plus x squared. Okay then, that's all well and good so far. 25x squared. Come on, let's start sorting it out. So 16x squared. Minus 10 plus 6 is minus 4x. 1 take 1 dies. Okay, and that equals 8 minus 16x plus 8x squared. So 8x squared. Add that over, plus 12x. Take 8 is equal to 0. We can divide through by 4 here. So 2x squared plus 3x minus 2 is 0. 2x, x, I'm hoping it factorizes. So we just need like a plus 1 plus 2 minus 1, I think. So 4x take x. Yep, that looks good to me. So x is either half or x is minus 2. But since x corresponds to an actual measurement, we must have x is positive, or 0 I guess. So x is 1/2. That was a good question. There are 4 types of cards in a game. Each card has a black circle, or a white circle, or a black triangle, or a white triangle. Oh, it's one of these horrible ratio questions. They love to ask it. They love to do it. So the number of black cards to the number of white cards is 3 to 5. The number of cards with a circle to the number of cards with a triangle is 2 to 7. Express the total number of cards with a black shape as a fraction of the total numbers of cards with a triangle. Oh. Total number of cards with a black shape as a fraction of the total of number of cards with a triangle. Right, let's just start. So number of black to number of white is 3 to 5. Circle to triangle is equal to 2 to 7.
They're trying to get you to figure out how many cards there are.
No, we can't do that.
I think you need to use the fact about like B plus W.
I'm gonna because I was about to get there. So the only thing I've
Oh, sorry, apologies.
is the fact that the number of black plus the number of W is equal to the total. So it's exhaustive, isn't it? So because they're the only types of cards. So white plus black is equal to the total, which is C plus T.
Sorry, very bad manners on my part there.
No, it's alright, it's alright. Does make command nicer. Because I want to use that. Oh, why don't I just use that? So it's 2/7 of T. So 8B is equal to 3 2/7 of T plus 3T. Yeah.
I didn't get that. I went about this in a different way. I sort of said there was a multiple of 45 cards because you've got. Oh wait, no, sorry, no, I did something wrong. It's all right.
Yeah. So the bit that I don't follow is the line where you go 5. Oh, so you've substituted the 5 and then you move the 3 over there. Okay, I'm on it. I'm with you again now. 270. 21 over 70. Yeah, so 6 plus 21 is not 126. So where does the 126 come from?
Yeah, that's a really good point. I'd multiplied them. So that's 27 on 7T, isn't it? So that's the answer,
Yeah.
I guess. So, well, and then we need to divide by 8.
Yes.
So B is 27 on 8 by 7, 56.
Yeah, that's what I've got. I've got 27 over 56.
Right. Okay. Well, yeah, I'm not sure about that question. It's a bit of a meal, isn't it?
Yeah, it's kind of awkward. I don't love it. So, Alex, we've got to the end of this paper and we're on the last one. I did order you a geometry set from Amazon,
Oh, you're
and
joking.
I did, and the gentleman from Amazon has just made an attempted delivery and he couldn't find you. So I'm sorry to say you won't have the protractor. I was really hoping you'd have the protractor for your last paper,
That's a
but
shame.
you won't. I'm sorry about
Hopefully, hopefully I won't be in need of an angle measurer for the last
that.
paper.
But you'll have one
Hold
for
on.
next. You'll have one.
Hold on. The Amazon guy turned up, couldn't find the door. Is this what happened?
Well,
And then left?
I've had an attempted delivery, and it just says we need more address detail. But I have put Alex's address, and we will have to be careful not to say Alex's address out loud on YouTube, obviously.
Of course. Yep.
But I did type in the same address that I've used on many occasions, and they've apparently given up. But perhaps it is Sunday morning, so we'll let him off.
Yeah, they can be terrible. Like, you know when you're waiting around all day and you've got your phone there right in front of you, you're sat watching the window, and then you suddenly get a ping that says a delivery was attempted. It's like, well, no, it wasn't.
Anyway, last one.
Last one. Thank God. All right, so this is same scheme. It is the second paper. Let's do it. I've got an hour and 20 minutes, which is about as long as you're supposed to get for this paper. So this is luxury.
Good stuff. And thank you to Dan's mum, Deborah.
Thank you, Dan's mum. You are wonderful. Okay. So 84 as a product of prime factors. My favorite. So that's 2 squared times 3 times 7, yeah? Lowest common multiple of those. Well, 60 is 2 squared times 3 times 5. So the lowest common multiple will be 2 squared times 3 times 5 times 7. So that is going to be what? That's going to be 60 times 7. So 420. Okay. So another Venn diagram. Got a few of these tonight. So the even numbers, and the only even factor of 10 is that. Oh, well, there's 10 itself. And then we've got 5, and we've got 1, and then we've got 4, 6, and 8. Anything else? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A probability is chosen at random. From the probability, so a fifth. Carlo puts tins into small boxes and, wouldn't you know it, into large boxes. He puts 6 tins into each small box. He puts 20 tins into each large box. He puts a total of 2,000 tins into boxes, so that the ratio of the number of tins in small boxes to the number of tins in large boxes is equal to 2 to 3. Sheesh. Carlo says that less than 30% of the boxes filled with tins are large boxes. Oh, I hate this. I hate these questions. Why are they so fiddly? Okay, so the number of tins in each. So, oh, God's sake, I hate it. I don't think this is the right way to do it. So the number of tins. So the number of tins in small boxes over the number of tins in large boxes is 2 to 3. Right, I think I can make this. What am I doing? So it's the number of tins. So 3,000 into this ratio 2 to. Let's do that. So that's 1,200 to 1,800. So there's 1,200 tins in small boxes. Yeah. So how many small boxes is that? It's 200 small boxes, and 1,800 on 20 is 90 large. So less than 30% of the boxes filled with tins are large. So 90 over 290 is the actual percentage. Which is 31%. So no, because it's greater than 30%. Complete the table of values. Fine, if I must. 13, 5, 4, minus 3. Yeah, because we still got that inflection point there, don't we? So we've got 13, 6, 5. Yep, that'll do. Okay. The diagram shows a right angled triangle and a quarter circle. The right angled triangle ABC so three significant figures. Okay. So the price has been reduced by 5%, and it's equal to 551. The price is not another one. Write down 2 things I should do to make the box plot fully correct. Median at 162, not 161. That's what you should do. What about the other numbers? That looks good. That looks good. That is bad. The upper quartile isn't on there, but we've got the interquartile range. So 154 plus 17 is 171, and that's in the wrong place. So upper quartile should be at 171, not at 172. 1, 8 over x minus 4, and that's 27 n to the power of 12 w to the power of 6. Right, I will actually just be back in 1 minute. I know it's the last paper and everything, but we'll be back in a sec.
I like that question 10A. I can imagine people getting stuck on that.
Yeah, I probably would as well. But I would know what the answer was because of how many marks there were.
yeah, it's a bit of a giveaway, isn't it?
Yes.
Yeah, just for people watching and not sure what's going on there. Essentially, it's just the thing of anything to the power of 0 is 1. So they've given you an expression and then they've just raised it to the power of 0. And so it doesn't matter what's inside the brackets, and anything you put inside those brackets, and then you raise it to the power of 0, the answer is going to be 1. So almost a borderline trick question there, I would say, but I quite like it. And then we've got Jack in the restaurant as our next thing. What do you think about those stem and leaf questions, Dan?
They're kind of boring.
Yeah, they're dumb, aren't they? Yeah, they are dumb.
Yeah.
Yeah. I wrote my long diatribe about it in the chat where I was sort of saying, well, Tukey came up with this stuff in the 70s, and it was also Tufts, big visualization guy.
Yeah, when would anyone ever use it?
It dates from the days when computers were not that easy to use to generate visualizations, and so but a lot of computers at that time would have had a monospaced font, and so computers are pretty good at ordering text and printing it out. So it's a very cheap way of visualizing the empirical distribution of a sample. Oh, good point, Jacob. Yeah, it is nice. So the point that Jacob's making is that if what you put in those brackets could potentially be 0, then you have the situation that you have 0 raised to the power of 0, which is one of those edge cases that undergraduates can spend a lot of time pondering. But yeah, in this case, 1 over m squared, that can never be 0. So we don't have that ambiguity here, which is nice. Although I suppose we also do have the situation where m could be 0. So we do have the 1 over 0 to the 0, which is also a bit of a dubious case. But yeah, just on the stem and leaf thing. So yeah, so it dates from the sort of monospaced font, printing things out in a monospaced font, and it's just a very cheap way of visualizing the empirical distribution on a computer that way. But these days it's completely irrelevant. You should just open up R and draw a histogram. But nonetheless, we're still making people do it on these papers for reasons that are not wholly clear to me, really. Especially since we make them draw histograms as well. So, anyway.
Are they still on the syllabus?
Yeah. I mean, this is from 2020, right? So.
Yeah. I mean, I saw one paper where it was on in 2012. Yeah, but it was on this paper. Yeah.
I think it was on the previous one, but that was also 2020.
But yeah.
But yeah, it's interesting. I mean, it's a nice bit of history. You know, the whole Tukey exploratory data analysis thing in the 70s is an interesting chapter of history, but
it doesn't get taught as a piece of history.
No, it doesn't get taught as a piece of history. It just gets taught
or even
as
a piece of
that you
data
have to go through.
Yeah, or even as a piece of data visualization. It is just
yeah. So they basically teach it
as a method,
as a really awkward way of getting the median. Oh dear. Yeah. So no. Yeah. I don't know. I mean, you could probably make an argument for it from a sort of number sense perspective. Kind of forces people to like, you know, do a process with I don't know, but yeah. So I don't love that. How about these algebra questions as well? I mean, I do wonder. Like, so if you give up maths at 16, and in these papers you're having to do these kind of simplified questions, it must seem a bit arbitrary.
Why?
Very useful if you're doing A level to build these fluencies, but not sure about how useful it is for people who this is the last qualification in maths that they do. Yeah. Because they're kind of shorn of context. Anyway, he's back now, so we got probably 12 more questions, something like that, and then we're done.
And then we are done. Yeah, I love 10A as well, and yeah, that's a really good observation there from JP as well, because there's always the question of what is 0 to the power of 0, but of course you got 1 on m squared, which can never be 0. You know, so you might think 0, you might think 1, and I think it is context dependent, isn't it? You know, whether you want that continuity there or not. Anyway, come on.
You can do this. You got this.
I feel so terrible. I can't wait to just go to sleep.
You got this.
Jack is in a restaurant. There are 5 starters. This is going to be a combinatoric sort of question, isn't it? 8 mains and some desserts on the menu. Jack is going to choose 1 starter, 1 main and 1 dessert. There are 240 ways he can choose. Could Jack be correct? Oh, that's nice. So 4 times 8 is 40. So 40 does divide 240. So yes, he could be correct. There could be, 6 desserts, right? Okay, the graph gives information about the volume V litres of petrol in the tank of Jim's car after it has travelled a distance of d kilometres. Find the gradient of the graph. Now, I had no idea that cars consumed petrol at such a nice linear rate like this, but let's just do the whole thing. So we go down by 27 across by 300. Whatever. Interpret what the gradient of the graph represents. Okay, so I guess the rate of change of volume per distance.
Yeah, I mean,
the rate of volume decrease per unit distance.
being creative, I suppose you could say the fuel efficiency, couldn't you? But...
Oh yeah, that's probably what it's looking for, isn't it? But I don't care. So A, B. All right, this is your bog standard sine rule question, isn't it? Except we do need that. And as I tell my students, there's no such thing as a triangle for which you only know two of the angles. You always know the third. So this is 180. That's 120, right? So we have x over sine 34 is equal to 23.8 over sine 120. So 23.8 sine 34 over sine 120. That's equal, so x equals 21.7. Sure. Here are two squares, A and B. The length of each side of square B is 4 centimeters greater than that of side A. The area of the square B is 70 times greater than the area of square A. Find the area of square B. So x squared plus 8x plus 16 is equal to x squared plus 70. They die. So x is equal to, oh, this is nothing nice, is it? 54 over 8. Three significant figures. So the scale factor must be minus 1.5, and the center of enlargement, well, there, isn't it? Yeah, center 1, 1.
Yeah.
Another quadratic sequence. So 11, 17, should be 23. Yeah, so 6, 6. So it's a 3n squared sequence. So as I like to say, it's 3n squared plus a linear bit. So quadratic bit is 10, 21, 38, 61. The 3n squared bit is 3, 12, 27. 4 squared is 16 times 3 is 48. And then our linear bit is the subtraction. So 7, 9, 11, 13 and so on. So the linear bit is equal to 2n plus 5. So it is 3n squared plus 2n plus 5.
Nice one.
Okay. Diagram represents a solid cone. Cone has base diameter that, slant height that. The circle is drawn around the surface of the cone. So hard to concentrate. It really is. It did not affect me like this at all last year. Last year I felt like I just did it and it was all fine.
You did get a bit punchy towards the end last year as well.
Not like this. Not like this, where I can feel myself falling asleep. Like if I close my eyes for a second too long, I actually kind of feel like I'm dozing off. I read the question and then I have to read it again because I'm just so sleepy. Right. So the surface area of the whole cone then is it's pi r squared plus pi r l. So the slopey bit is given by, oh, it's actually given to us there. And r is 10 in this case. So this is 100 pi plus 250 pi is 350 pi. And the surface area of the shaded bit is just equal to, now, interesting question, what is that? So we're going to have to use the fact that these are similar shapes. So how do I get from 25 to 15? I times by 3/5, is it? Yes. So then I times 10 by 3/5 and I get 6. So that radius there is 6. So pi r l, where we've got pi times 6 times 15, which is equal to 90 pi. So what we want is 350, subtract that shaded bit, is 260 pi. Yeah, it seems quite big compared to, but I suppose the bigger you get, way more area down here, and you've got the flat bottom as well. So I suppose I can believe that.
Yeah, I'm with it.
A hot air balloon is descending. What do you call a snarky prisoner going downstairs? A condescending.
Oh boy! Wow.
Such a good joke. I love it. Okay.
It is. No, that it is. It's a very good joke. It is. That's. I appreciate it.
The height of the balloon n minutes after it starts to descend is given by hn. The height of the balloon n plus 1 minutes is given by hn plus 1 meters. And is given by that, where k is, oh god, I'm getting flashbacks to that horrific integrals question in the further maths paper. The balloon starts to descend from a height of 1200 meters at 9:15. God. So, H1 then. I don't know why it gives me this, because that to me is H0. So H1 is that. So I don't know why we can't use it. So that, I think, 3 minutes after it starts to descend at 09:15.
Yep. Spot on.
So 16, 17, 18, yeah.
Spot on.
Okay, there are only red sweets and yellow sweets in a bag. There are n red sweets in the bag. There are 8 yellow sweets in the bag. So that's the total number of sweets. Sajid is going to take a random sweet from the bag and eat it. He says the probability that the sweet will be red is 7/10. Okay, show why it can't be. So assume P of red is 7/10. Then n over n plus 8 is equal to 7/10. Because that's the probability of red. So 10n is equal to 7n plus 8 times 7, go on brain, 56. So then 3n is equal to 56. Therefore n is bad. Then n is not an integer. After saying he's taking the first sweet from the bag and eating it, he's going to take a random second sweet from the bag. The probability that they are both red is 3/5. Work out the number of red sweets in the bag. So we've got n over n plus 8. That's the number of sweets. That's the probability he chooses red on the first draw. Then the probability that he chooses red again, there's one less red and one less total sweet. So n times n minus 1 times 5 is equal to n plus 1, so n plus 7, n plus 8 times by 3. Sorry, what am I doing? This is I'm genuinely like I'm falling asleep here. I've honestly just written total nonsense here, haven't I? N minus 1 over n plus 8 n plus 7. Wow, my eyes just completely glazed over there. And that's equal to 3. Oh no, so I am doing the right thing.
Yeah, you're doing the right thing.
God, yeah,
you're doing the right thing.
Yeah, I just woke up and realised, what on earth am I doing? I was sleep mathsing.
Pilot mode.
But what you'd written was actually correct.
Yeah.
Yeah.
I don't know.
Bad.
It's the amazing thing. 15n. But I just didn't trust myself. That's. How many of these have we had to do? You know, where it's just so. So minus 5, subtract 45 minus 50n, and 56 times 3.
Oof.
Minus 168 is equal to 0. That means n squared minus 25n subtract 84 is equal to 0. Come on, this has got to factorize.
Yeah, it does have to factorize. Because it's
an integer answer, yeah. So let's see about that then. So that's equal to 84. It's 7 times 12. Needs to be more spread out than that. So what about 14 times 6? 21 times 4. So minus 21. But that's a negative there. Oh. Am I supposed to have positive? I don't think so.
Minus 28 plus 3 from Catherine.
Yes. I would have got there eventually.
Catherine, you've been the MVP in this stream, I think. You got us out of trouble a few times.
So n equals 28. And what was the question? Oh, that was it. 28. Yeah?
It's the number of red sweets, right? Yes, 28.
There are n red sweets, yeah.
Yeah, n red sweets, 28.
That's what I was just double checking, because I'm like, so many little bits and pieces to that. Great, just 2 questions to go, is it?
Yeah, I think so.
All right. So the graph of a curve with equation of y equals f of x. The graph above, draw the graph with equation f equals negative x. So this is a reflection this way. Something like that. Okay, the curve C with equation y equals 5 plus 2x minus x squared is transformed by a translation to give the curve S such that the point 1, 6 on C is mapped to point 4, 6. Find an equation for S. So we're going from C to S. This is a translation of 5 in the X direction. So 5 plus 2 x minus 5 minus x minus 5 squared. I know we don't, it just says find an equation, so I'm going to stick with that. I don't see any need to really sort that out.
Nope.
C is a circle with center origin. Tangent to C passes through minus 20 and 10, so something like that. Work out the equation of C. Right. Okay. So somehow, based on the fact that this is 10 and this is 20, it thinks we are able to work out that. That's the goal. Wrangles. Well, okay. So we can do it like this actually. So we have call that L1. So L1 is such that it's got a gradient of half and a y-intercept of 10. And now this line here is y equals minus 2x. It has to be perpendicular to this. Passes through the origin, so it's just plus 0 on the end. So in other words, minus 2x is equal to half x plus 10. Minus 4x is equal to x plus 20. So 20 is equal to 5x and x is equal to 4. So what? Minus 4, thank you. So that is minus 4. And so y is equal to half of minus 4 plus 10 is equal to minus 2 plus 10 is 8. So we've got a good triangle now. R 8 4. So R is the square root of 8 squared plus 4 squared. This is nothing nice, but it is what it is. Plus 4 squared equals 4 root 5. In fact, you know what? I'm going to keep it as R squared because that's 64 plus 16 is 80. Because now the equation of the circle is x squared plus y squared equals 80. And we are done.
Well done, fella. Nice way to finish as well. That was a clever way of doing that one. I like that.
Yeah, I don't think that's the proper way. That seemed like a lot of work. I don't know if there's a smarter way to use those triangles that we get given.
No, I don't think so. I was going to brute force it. I would have just written down the equation of the tangent, equation of the circle, and solved them, which I think would have been a very unpleasant thing to do.
yeah, I wouldn't have bothered with that.
Yeah. So I think what you've done is like, I think there's a bunch of ways of doing these kind of questions. To be honest, like the fact that the circle has its center at the origin is just nice, right?
It's always center origin in a GCSE anyway, but
there's loads of ways to do it. I mean, you could have done so. You could have started messing around with angles and all sorts of stuff, but there's probably a similar triangles thing going on as well. But
well, I think they are similar. Yeah, but it's just you don't get that much info. Like those triangles are quite divorced from each other, which is like quite annoying.
yeah.
This is the only way I could see of doing it.
But no, I like this a lot. Yeah.
I mean, what they love to ask is you get the equation of the circle, find the tangent at a certain point. They love to ask that question, and this is how you do it. So I just kind of, if you do that backwards, you'll end up with the equation of the circle. Right. Well. Oh my God. With an hour to spare, but this was really hard. The first year I did this, I absolutely loved it. I had a great time. Yes, towards the end I was getting a bit tired, and I was struggling through some of those. I remember that. I distinctly remember that ODE where I just couldn't make it work. But this time it felt a lot worse, and I don't know if it's just because last night, well, 2 nights ago now, I just had the worst night's sleep, so I woke up in a pretty bad mood, and I just didn't want to do it, but I thought I've got to do it, and here we are. I don't know what it was. I just really struggled this time. I don't think I enjoyed the last 8 hours of that.
But nonetheless, you've raised a fantastic sum for Refuge, nearly £1,000. So I think that that's a big achievement.
I don't know if you were on the call before. We did a sweepstakes. I won the Grand National with my friends yesterday, so I'll put the money from that towards that. See if we could just break that 1,000 barrier. That would be
nice.
That would be really nice. I don't know how much that sweepstakes is going to actually be. It's probably not going to be a great deal because it was just a sweepstakes. It was. I don't think we actually bet on the horse.
Well, let's just hope that there's. All you need is 35 in there. So I think there are 35 horses more than 35 horses in the Grand National, right?
Yeah, but there was a first place, second place, third place. So I don't know.
Yeah.
But
yeah. Anyway, so a grand for Refuge, which is obviously a super cause, and I think I can't imagine they're going to be turning their noses up at it. So I think that's awesome.
No. I think it's easy to get put off by the fact that I set the target so high and lose sight of the fact that it is still £1,000, which is fantastic. Thank you.
It's awesome.
So much to everybody who donated. Thanks to everybody who was watching along. Thanks. Thanks, Catherine. You really saved me plenty of times there. Thanks, Jacob, for all of your support. I noticed you in the chat quite a lot. Oh, around £60 is what I won for that Grand National. So that'll easily tip it over that 1,000 mark. So that's fantastic. And thank you very much, James, for joining the call, even on your birthday, which is for the second year in a row. Let's try not to make it a regular thing.
I don't mind.
I think I'll give it a couple of years before I do this again.
Yeah.
Last year, I was absolutely on fire. I was like, I want to do this every year from now on. I just absolutely loved it. After this time, I'm like, geez, maybe.
Wait till you have a good night's sleep in you or a good day's sleep in you, and then think you'll think more clearly in the morning whether you'll do it again.
Yeah.
Maybe we'll do a relay or something. We can take
something like that. Yeah, that'd
make
be
it
fun,
less
wouldn't
painful.
It? Yeah. So thanks very much, Jay. Thanks very much, Dan. You were with me for I felt like the majority of that. And thanks very much to Creamer. He was up until about 1:30 last night with me. So
wow.
That was real commitment as well. So all good stuff.
Brilliant. And we should thank all our parents as well, despite none of them particularly. Well, I suppose shouldn't my mum's pretty sharp mathematically, but I don't know about the rest of them. So thank you to all of our parents as well.
Yeah, absolutely. Yeah, thanks to my to my old man. He's on Canada time, so it's quite natural for him to stay up. He's staying up having a few beers while I'm toiling away at like 3 a.m. So, but it's always nice to get those supportive messages. I am going to go.
Yes, I think you should go as well.
I'm so done with this. But thanks again to everybody. It's been something. It's been something.
Good clean fun.
All right, guys. I'll see you later.
All right. Good.